Hey, gems of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question paper, actually all the entrance exam question papers. For a better preparation, you must download our app. The link is available in the description box. So very best of luck, students. Today we'll be solving TS EAMCET Engineering 14 May 2023 Shift 2 paper. You are having physics, chemistry, and mathematics portions. And in this particular video, we'll be focusing on the mathematical part of your paper. A very best of luck. Let's start with the question number 1. Here we go. Let f be the function from real to real numbers defined by fx is equal to this when x is less than 2 and this when x is greater than equal to 2. Then the number of real numbers x for which fx is equal to 8 is. Okay, so see, you're having two cases over here. This is case 1 and 2. First, fx is equal to 8, right? That means I'm going to pick up this one. X minus 3 is equal to 8, which gives me x is equal to 11 as x is greater than 2. Also, it is x squared minus 4x plus 3. This is equal to 8, right? So this will be equal to x squared minus 4x minus 5 is equal to 0. So the two factors will be minus 5x plus x minus 5 is equal to 0. So the two factors will come out to be x minus 5, x plus 1 is equal to 0. So that means x may be equal to minus 1 or 5. Now, here x will be equal to minus 1 as I'm picking up this particular equation as x is less than 2. So how many number of solutions are there over here? 1 and 2. That means 2 solutions. Option B is the correct answer. Hope you understood this. Next is question number 2. If fx and gx are two real valued functions such that fx is equal to this and gx is equal to this, then what is g of f plus f of g of x? Okay, so you have the two functions. Let's write down those functions. Fx is equal to 3x minus 2 and gx is equal to x squared plus 2. First one, you have to find out g of f. This is equal to 3x minus 2 square plus 2, which will give you 9x square plus 4 minus 12x plus 2, or you have 9x squared minus 12x plus 6. Second, f of g of x is equal to 3x squared plus 2 minus 2, which gives you 3x squared plus 4. Now adding both of them, g of f plus f of g of x. This is equal to 9x squared minus 12x plus 6 plus 3x squared plus 4. So here you have this as 12x squared minus this plus this. Okay, fine. So let's check, but I have the answers in the form of G and F. So what shall I have to do? I have to change it a bit. So what shall I do over here? This is equal to, I'm taking 12 common, x squared plus 2 minus 4. Wait, what is this? Fx was 3x minus 2. 3x minus 2. See, I have adjusted both the x's now. This is 12x square, which has been used, and minus 12x has been used. Now, what extra is in this part? There is 24 extra here, and there is 8 extra here, right? So, plus these two things. And there is a plus 10. That means what I have to do, this is 32. So, I have to subtract. I have added this much, so I have to subtract 32 from here. I hope you're getting this because I have used 24 here, 8 over here. That means a total of 32 plus 32 has been used over here. So I have to subtract 32 from here plus 10 from this one. So this will be 12 x squared plus 2. This is g of x minus 3x minus 2 is f of x minus 32 plus this will be minus 22. Okay, so that's it. This is your answer. 12gx minus 4x minus 22. This is option B. Hope you understood this. Next is question number 3. Fx is a real valued function defined by this, and f of 4 is equal to minus 4. Then what is the value of f of minus 4? Okay, actually, this is quite easy. You are given fx is equal to this. Let's write it once. Fx is equal to a x raised to power 10, b x raised to power 8, c x6, d x4, e x square 12x plus 15 whole divided by x, which can be written as a x raised to power 9, b x raised to power 7, c x raised to power 5, d x raised to power 3, e x plus 12 plus 15 upon x. Now, let's say this is gx. Okay. Now, this is an odd function, right? This is an odd function. So we have a g of minus x is equal to minus gx, which means minus 4 is equal to f of 4. This is equal to g of 4 plus 12, or g4 is equal to minus 16 and g of minus 4 is equal to 16. That means f of minus 4 is equal to g of minus 4 plus 12, which is 28. Hope you understood this. 28 is the answer to the question, and option A is the correct answer. Hope you got that. Next is question number 4. If x 4 by 3, y 4 by 3, p 2 by 3 are the matrices of the order, then the order of this matrix is equal to. Okay, fine. You are having these matrices. X is having the order 4 by 3, y is having the order 4 by 3, and p is having the order 2 by 3. So since you have a p, I'm picking up from here, p 2 by 3, x raised to power t. So x was your 4 by 3, y 4 by 3 raised to power minus 1. So, okay. Next is p raised to power 3, and p's order was 2 by 3. So this is equal to p 2 by 3 x t y. This, see, both are having order 4 by 3. So this is 3 by 3. The columns of this and the columns of this. So this will be 3 by 3. Wait, sorry, I did a mistake. This is x was question number 4. If x is a matrix by the order of 4 into 4 by 3, y is the matrix 4 by 3, and v is the matrix 2 by 3, are the matrices of the order, then the order of this matrix is. Let's discuss the orders. So let's write down your here having here p x x transpose y inverse p transpose the whole matrix transpose. So let's write down the orders now. So p is having the order 2 by 3 brackets x transpose. So x order is 3 by 4. The order of the transpose will be equal to this was x order was 4 by 3. So x transpose order will be 3 by 4. Y, the order of y is 4 by 3. Whole inverse p transpose. So this will be, the order will be given by 3 by 2. The whole thing transpose. Now, this is equal to p order 2 by 3 x transpose y inverse. Because I'm multiplying both of them, I'll pick up the number of rows of the first and the columns of the second. So this will have the order of 3 by 3. P transpose, which is having the order of 3 by 2, the whole transpose. That's equal to, this is being multiplied. Wait, this is like this. All are being multiplied. So this thing, P X transpose Y inverse, this will have the order of, and here was P transpose as well. So this is having the order of 2 by 2, the whole thing transpose. So when I'm doing the transpose of it, again, the order will be the same, P X transpose Y inverse P transpose. The whole transpose order will remain 2 by 2. So that means you have option D as your answer. Hope you understood this. Next is question number 5. If A is the matrix given by this and alpha beta belongs to the rational numbers, then such that alpha into A square minus beta A is equal to 2 identity matrix. Then what is the value of alpha square plus beta? Fine, I need A square first. So you are having the matrix 1, 2, 3, 5. What will be A square? It will be this multiplied by this. So this will be equal to first row, first column. That's equal to 1 plus 6, 2 plus 10, 3 plus 15, and 6 plus 25. So this is equal to 7, 12, 18, and 31. Now, alpha A square minus beta A is equal to 2 identity matrix. That gives you alpha 7, 12, 18, 31 minus beta 1, 2, 3, 5 is equal to 2 identity matrix 1, 0, 0, 1. This gives me 7 alpha. I'm just like subtracting them side by side. Okay, 7 alpha minus beta, 18 alpha minus 3 beta, 12 alpha minus 2 beta, and 31 alpha minus 5 beta is equal to 2, 0, 0, 2. And now from here you have 7 alpha minus beta is equal to 2, 12 alpha minus 2 beta is equal to 0, 18 alpha minus 3 beta is equal to 0, and 31 alpha minus 5 beta is equal to 2. So let's solve that. Here you have 6 alpha is equal to beta, right? So from here you will have 7 alpha minus 6 beta is equal to 2, which gives you beta is equal to 2. And you also got, so it was supposed to be 6 alpha. So alpha is equal to 2. And yeah, alpha is equal to 2 and 7 alpha minus beta is equal to 2. That makes 7 into 2 minus beta is equal to 2. That gives you 14 minus 2, beta is equal to 12. So got the values of alpha is 2 and beta is 12. You have to find out was alpha square plus beta. So this is equal to 16. This is the answer to the question. Option B is the correct answer. Hope you understood this. Next is question number 6. Again, a determinant you have, matrix problem. So this is equal to K and alpha is equal to minus 2. Then what is the value for K? So let's fill in the alpha is equal to minus 2 directly over here. You will have a minus 1 square, 0 square, 1 square, 1 minus 4. This is equal to minus 3 square. I'm directly writing 9 over here. And that's minus 2 square, that is equal to 4. And 3 minus 6, which is, sorry, 3 minus 4, that is minus 4 square, that is equal to 1. Okay. Then you have 1 minus 6 minus 5 square, 25. Then 2 minus 6 minus 4 square, 16. Then 3 minus 6, that is 9. Okay, this is equal to K. So let's write it properly once. This is 1, 0, 1, 9, 4, 1, 25, 16, 9 is equal to K. Let's find out a determinant now. So this is 1, 36, like 4 9s are 36 minus 16 and minus 9, 0 minus 16 plus 25, 0 minus 4. That gives you 20 plus 16, 9s are 44. And this is equal to minus 100. This is 20 plus 44, which is equal to 64. So k is equal to 64. This is the answer to the question. You don't have any options, but the answer to the question is for sure. K is equal to 64. So answer is equal to 64. Hope you understood this. Let's move to the next question. The equations are this, and this. Where lambda and nu belongs to a rational number is solvable by matrix inversion method, then which of the following is true? See, you have the system of equations. You have three equations. These are x plus y plus z is equal to 5. X plus 2y plus 2z is equal to 6. And x plus 3y plus lambda z is equal to mu. Since the equation is solvable, that means the determinant is not equal to 0. So let's find out determinant now. This will be 1, 1, 1, 1, 2, 2, 1, 3, lambda. Now this is the determinant is not equal to 0. That makes it 1, 2 lambda minus 6 minus 1. This will be lambda minus 2 plus 1, 3 minus 2. This is not equal to 0. So this will give me 2 lambda minus this minus lambda plus 2 plus 1 is not equal to 0. That gives you lambda minus 3 is not equal to 0, which means lambda is not equal to 3. And you are given that mu belongs to rational numbers. It's already given over here. So let's check. This is option A. Lambda doesn't belong to 3, and lambda is not equal to 3, and mu belongs to the rational numbers. That's it. You have option A as the answer. Next question, number 8. X is equal to A plus B. Y is this? Z is this. Alpha and beta are complex cube roots of unity. Then what is the value for x cube, y cube, and z cube? You are given alpha and beta are the cube roots of unity. So let's say alpha is equal to omega and beta is equal to omega square. Okay. So that means you have add x plus y plus z. So I'm adding these three equations. You will have this as a plus b, a alpha plus b beta, a beta plus b alpha. So let's add all of them. You will have, I'm taking the a common. So this will be 1 plus alpha plus beta, and then the b common 1 plus alpha plus beta. And what was alpha? This was omega and omega square. You know one thing, that 1 plus omega square is equal to 0. So that means 1 plus alpha plus beta is also equal to 0. So this gives me a into 0 plus b into 0, which is equal to 0. That means x plus y plus z is equal to 0. And now you have to find out x cube plus y cube plus z cube. This is equal to 3xyz when x plus y plus z is equal to 0. So that means you have this as a 3 into what is x, y, z equal to? We have to solve that. X, y, z is equal to, this is a plus b multiply a alpha b beta multiply a beta plus b alpha. So this is equal to a square. I'm going to solve it here. This is an open space, so better to solve it here. A into beta plus b into alpha. So this is it. You have a square alpha plus ab beta plus ab alpha and b square beta whole multiplied by a beta plus b alpha, right? So here you have a cube alpha plus a square b alpha square plus a square b beta square plus a b square L beta into alpha plus A square B alpha beta plus AB square alpha square plus AB square beta square plus B cube alpha into beta. Okay, now further, you know one thing that 1 plus alpha plus beta is equal to 0. So here you have, I'm taking the question number 8. If x is equal to a plus beta, y is this, z is this, then alpha and beta are the complex roots of unity. You have to find out the value of x cube plus y cube plus z cube. You are given that alpha and beta, they are the cube roots of unity. So let's say this is omega and this is omega square. So when we have two things, 1 plus alpha plus beta is equal to 0. Why is that? Because you know that 1 plus omega square is equal to 0. That's why 1 plus alpha plus beta is equal to 0. Also, if I say x, y, z, I multiply all of them, this will be a plus b into a alpha, b beta, a beta, b alpha. So this can be written a plus b. This is a alpha is equal to omega and beta is equal to omega square, a omega square, and you have b into omega. Okay, one thing you have, 1 plus omega square is equal to 0, and also omega cube is equal to 1. On solving this whole thing, so when you open it up, it will be a square omega plus ab omega square plus ab omega plus b square omega square. This whole thing multiplied by a omega square plus b omega, right? So here you have one thing. Let's open it up again. So omega cube, sorry, a cube omega cube uh, plus a square b omega square plus a square b omega raised to power 4, which can be written as omega only because omega raised to power 4 is equal to omega cube into omega, which is equal to omega only. So this is equal to omega square b omega plus a b omega cube. I'm writing just like that. And then you have a square b omega cube. I'm just letting it write like that only, plus a b square omega square plus a b square omega raised to power 4. I'm writing omega only. And plus this is equal to b cube into omega cube. That's it. That's b cube only. Okay, I'm writing this also because this is only omega cube. Sorry, a cube. So a cube plus b cube. I have written like this two things over here, and then I have plus a square b. I'm taking common, so this is 1. This is a square b omega, and this is omega square, right? And then I have to take give me a minute. So this was ab square. Yeah, this was AB into this. So this was AB square. Now I'm taking AB square as common. This will be 1 for this. And then omega and omega square. So this will be equal to A cube plus B cube plus 0 plus 0, which is equal to A cube plus B cube. That means you have the product of these three given numbers x, y, z as A cube and B cube. Now, one more thing, let's add them. So you are adding a plus b plus what is next? A into alpha, b beta. So a alpha, b beta plus a beta, b alpha, right? So I'm taking the a common now, 1 alpha and beta. Similarly, plus b, 1 plus alpha plus beta. We already solved in the starting, 1 plus alpha plus beta is equal to 0. So I'm putting that. This will be equal to 0 plus 0. So that means this is equal to 0. Now, to find in the question was x cube plus y cube plus z cube, which is equal to 3xyz when x plus y plus z is equal to 0. You know this formula. So what is 3xyz? This was a cube plus b cube. So this is the answer to the question. 3a cube plus b cube. Option B is the correct answer. Hope you understood this. Next is question number 9. So if z is a complex number, 3 plus 2 iota cos theta upon this is a purely imaginary number, then what is the value for this? Okay. So you are given z is equal to 3 plus 2 iota cos theta upon 1 minus 2 iota sine theta. Let's rationalize. So 1 plus 2 iota sine theta upon 1 plus 2 iota sine theta. This will be equal to 3 plus 6 iota sine theta plus 2 iota sine theta plus 4 iota square sine theta cos theta, whole divided by this will be 1 minus 4 iota square sine square theta. So that's you can say this is equal to minus, so this will be 3 minus 4 sine theta cos theta plus 8 iota. Wait, I did a mistake over here. This was 3 and this is 6 iota sine theta and this is 2 iota cos theta, not sine theta. Okay. So this is supposed to be, I'm taking here 2 iota common and this is 3 sine theta plus cos theta, whole divided by this is equal to 1 plus 4 sine square theta. Hope you understood till here. So you are given in the question that this is a purely imaginary number, which means the real part is equal to 0. Let's see the real part now. Real part for this complex number is 3 minus 4 sine theta upon cos theta upon 1 plus 4 sine square theta is equal to 0, which makes you 3 is equal to 4 sine theta cos theta, or 3 is equal to 2 sine 2 theta, or you have a sine 2 theta is equal to 3 by 2, which is actually not possible. The sign lies between minus 1 and 1. So this is not possible actually. That means the answer is not correct. Okay, you have to find out sine square theta plus cos square 3 theta. But actually this is not possible. So the question is not correct. Next is question number 12. If z is the complex number given by x plus iota y such that this is equal to 350 and x and y are integers, then what is the modulus of z? You are given the complex number is x plus iota y, and also you are given that z conjugate q plus, so this is 350. So I'm taking this common from here. Inside you'll be left with the z square plus z conjugate square. This is equal to 350. So see, when I'm multiplying a number, a complex number by its conjugate, then the result is always square of the x and y. Like if I'm having z is equal to x plus iota y, so this will be equal to x square plus y square. And what will be z square equal to? It will be x square minus y square plus 2 iota y plus x square minus y square minus 2 iota xy. That's equal to 350, right? So this is equal to x square plus y square, and here you have 2x square minus 2y square, and these two terms will cancel. So this is equal to 350. I'm taking the 2 common and dividing over here. So you will have x square plus y square into x square minus y square is equal to 175. X raised to power 4, y raised to power 4 is equal to 175, which can be written as 25 by 7. I'll rewrite this. I'll just let it be this only. X square plus y square into x square minus y square is equal to 25 multiply 7, which means this is equal to this and this is equal to this. So x square plus y square is equal to 25 and x square minus y square is equal to 7. That gives you 2x square is equal to 32, or x square is equal to 16, and y square will come out to be 9. Now you have to find out in the question was the magnitude of the complex number z, which is equal to root of x square plus y square. That is equal to root of this, which is 25 root, that is equal to 5. Okay, that means you have option B as your answer. Hope you understood this. Next is question number 11. Alpha and beta are the roots of this equation. Then alpha plus beta squared, alpha squared plus beta squared whole square, alpha cube plus beta cube whole square, so on till alpha raised to power 12 plus beta raised to power 12 whole square is equal to. Okay, so you are given the equation this, and you are given that alpha and beta are the roots. So by using the quadratic formula, this can be minus 1 plus minus, this will be iota root 3, because I'm using minus b plus minus root of this upon 2a. So this is a minus 1 plus minus 1 minus 4 upon 2. This is minus 1 plus minus, minus can be taken as iota root 3 upon 2. So this is the one, and yeah, you know, this is having the two values. This is equal to omega and omega square. So from here, you have the first one that you have to solve is alpha plus beta square plus alpha square beta square whole square plus alpha cube beta cube whole cube, so on, alpha raised to power 12, beta raised to power 12 whole square. And I see, you know, alpha, omega, and these are the two roots for this. So you can write it as omega plus omega square whole square plus omega square, omega raised to power 4 whole square plus omega cube, omega raised to power 6 whole square, so on till omega 12 plus omega raised to power 24 whole square. And you know, omega plus omega square, that's equal to minus 1. Wait, I'll just keep it like this. Omega plus omega square whole square plus omega square plus, this can be written as omega because omega raised to power 4 is equal to omega, plus so on till, okay, next one it will be, wait, this will be plus. So this is equal to 1, this is equal to 1, right? 1 plus 1 whole square. Then plus, again, you will have omega and omega square. This will go on. See, I'm starting with this, then 1 plus 1. So this will go on until the last one, this omega raised to power 12. This is also 1, and omega raised to power 24 is also equal to 1 whole square. So now let's fill in. You have here omega plus omega square. This is equal to minus 1. So minus 1 raised to power 2 plus this is again minus 1 raised to power 2 plus 2 square. See, this whole thing is being repeated how many times? 1. You have 12 terms. So this will be repeated how many times? It will be repeated 4 times. So that into 4. Right, this pair will be 4 times because there are 12 terms and they are having 3 pairs, so 4 times it will be repeated. Now this is equal to 1 plus 1 plus this is 4, so you have 24 as your answer. So that's it. Option C is the correct answer. Hope you understood this. Next is question number 12. So the least positive integral value of n such that this is equal to 1 is what? Okay, so let's write it down. You have 1 plus sine 2 pi upon n 9 plus iota cos 2 pi upon 9 whole divided by this minus this. This is equal to 1. It is given. And this can be written as 1 plus sine 2 pi upon 9 can be written as, because I'm adding pi by 2 to it. So this can be written as 5 pi upon 18 plus iota sine 5 pi upon 18 whole divided by 1 plus cos 5 pi by 18 minus iota sine 5 pi 18. This is also that this is equal to 1. It's given. See, what I've done is, because you have 2 pi by 9 is equal to this. Okay. And sine pi by 2 minus theta is equal to cos theta. You know this also. Cos pi by 2 minus theta is equal to sine theta. Okay, so here you have a 2 cos square 5 pi upon 36 plus iota 2 sine 5 pi upon 36 cos 5 pi upon 36 whole divided by 2 cos square 5 pi upon 36 minus iota 2 sine 5 pi by 36 cos 5 by 36 whole raised to power n. This is equal to 1. And here I forgot to write n over here. Okay, fine. So this is equal to 1, right? Also, this is, see, what I have used over here is, because 1 plus cos theta is equal to 2 cos square theta by 2, and sine theta is sine theta by 2 cos theta by 2. So this equation now becomes cos 5 pi by 36 plus iota sine 5 pi by 36 whole divided by cos 5 pi by 36 minus iota sine. This is equal to 1. Now multiplying with the conjugate. Multiplying with the conjugate, you will get here cos 5 pi by 36 plus iota 5 pi sine, sorry, iota sine 5 pi by 36 whole divided by cos 5 pi by 36 minus iota sine 5 pi by 36 multiply cos 5 pi by 36 plus iota sine 5 pi by 36 cos this plus this. So this will be equal to numerator square cos 5 pi by 36 plus iota sine 5 pi by 36 whole square upon a square minus b square. Iota square will turn into positive, so you will have cos square 5 pi by 36 plus sine square 5 pi by 36. That's equal to, okay, that's equal to 1. That was always equal to 1. I forgot to write that. So this is whole raised to power n. Okay. So this becomes now, see the general one, cos 5n pi upon 18 plus iota sine 5n pi upon 18, because denominator will be 1. So this raised to power n is equal to 1. So least positive integral value of least positive integral value of n is equal to 18. Okay, so that's it. This is the answer to the question, and you have option B as the answer. Hope you understood this. Next is question number 13. Alpha and beta are the roots of this equation. 1 upon alpha, 1 upon beta are the roots of this equation. Then what is the value for this expression? Okay, fine. So here you have the roots. The given equation is x squared plus a x plus 2 is equal to 0. And the two roots are alpha and beta. So you have the sum of the roots is given by minus the coefficient of x upon the coefficient of x squared. That means it's minus a, and the product of the roots is c upon a. That means it is equal to 2. Also, you have alpha square plus beta square is given by alpha plus beta whole square minus 2 alpha beta, which is a square minus 4. Hope you understood till here. Now, let's pick up this one to find. Wait, let's write down first. Alpha plus 1 upon beta, beta plus this, alpha minus this, and beta minus this, right? Let's solve this. Let's find the LCM. You have this alpha plus, sorry, this is alpha beta plus this. Alpha beta plus 1, alpha beta plus 1 upon alpha, alpha square minus 1 alpha, beta square minus 1 beta. And you know alpha beta, that's 2 plus 1 upon let it be beta only. And again 2 plus 1 alpha. Alpha square minus this, let's solve it. So this will be alpha square beta square minus alpha square plus beta square plus 1 whole divided by alpha into beta. So this will be 3 into 3, 9 upon alpha beta. And this is 2 squared, that is 4 minus alpha squared plus beta squared. We just solved that is equal to a square minus 4. Yeah. So this is a square minus 4 plus 1 upon alpha beta. So you have 9 upon alpha beta into alpha beta, which is equal to 4. And that's 5 minus a square minus 4. Right, so this gives you 9 by 4, and this will be 9 minus a square. This is the answer to the question. Right, 9 by 4, 9 minus a square. This is option A. Option A is the correct answer to the question. Hope you understood this. Next is question number 14. The sum of the real values of x satisfying this equation is given by. So you're given the equation, let's write it down. You are having x squared minus 7x plus 11 raised to power x squared minus 6x minus 7. This is equal to 1. So you have two cases, actually, three cases over here. Yeah, this is 1, 2, and 3. So for the first case, x squared minus 7x plus 11 is equal to 1. For the second one, this will be equal to x squared minus 7x plus 1 will be 0, minus 1, or this will be 0 and not 0. So actually 4 cases. Okay, so if I'm taking this, so x squared minus 7 squared plus 10 is equal to 0. This will be, I have to split it up, 5 x minus 2x plus 10. So you have two factors, x minus 5, x minus 2, which will give you x is equal to 2 or 5. Here you have x squared minus 7x plus 12 is equal to 0. Now you have 4 and 3. So the two factors, x minus 4, x minus 3, that means x can be 3 or 4. Right. 14. The sum of all real values of x satisfying this equation is equal to 1 is, see, you are having the solution as 1. So there are two possible cases when you can have 1 on the RHS. Whenever the this exponent is 0, right? The power is equal to 0. That simply means x squared minus 6x minus 7 is equal to 0. Or if this is not equal to 0, if this is, let it be, this is not equal to 0, then this thing, x squared minus 7x plus 11, this should be equal to 1, or this should be equal to minus 1. But if this is equal to minus 1, then one more condition has to be satisfied, which is x square minus 6x minus 7 should be even. I hope you understood like what I'm saying. Okay. Looking at all these scenarios, now we have 3 cases. Let's go. So first case, x square minus 6x minus 7 is equal to 0, right? It should be equal to 0. For that, the possible values of x will be x squared minus 7x plus x minus 7 is equal to 0. So you have the two factors as x minus 7, x minus 1 is equal to 0. X minus 7 and x plus 1, sorry. Yeah. X minus 7 and x minus 1 is equal to 0. So the two factors are x minus 1 and 7, right? For this thing, this should be, no, this should not be equal to 0, right? Second case, when x square minus 6x minus 7, this is not 0. When this is not 0, then you can have two cases. X square minus 7x plus 11, this should be equal to 1, or this should be equal to minus 1. But in that case, x square minus 6x minus 7, this should be even. Okay. And this is possible. This is even only when x is equal to 3. You can check that. Now, when you have this one, x squared minus 7x plus 10 is equal to 0. Two factors, 5x minus 2x plus 10 is equal to 0. X minus 5 minus 2. So the two factors are this, and the roots are 2 and 5. Similarly, for here, you have x squared minus 7x plus 12 is equal to 0. Is equal to 0, or x minus 4 minus 3, x minus 4 is equal to 0, x minus 3, x minus 4 is equal to 0, or you can have x as 3 and 4. So these are the four possible values, but this is possible only when x is equal to 3. So only this value will be considered, 4 will not be considered in this case. Hope you understood this. Now, what the question was, you want to find the sum of real values of x which are satisfying this equation. So sum of solutions is equal to 2 plus 5 plus this 3. I'm ignoring 4 because when you will put x is equal to 4, this will be negative. See, 4 squared minus 24 minus 7, 16 minus this. This is going to be negative. And you want the positive value for this. Sorry, this is going to be odd negative, actually. This is going to be odd negative, and we want it to be even. So I'm ignoring the 4 plus 3, and we have these two values as well, minus 1 and 7. Let's add these also, minus 1 and 7. This is equal to 14 and this, so 16. This is the answer to the question. Option D is the correct answer. Hope you understood that. Let's move to the next question. If a polynomial px is given by px is equal to this, such that p of 1 is equal to 4, p2 is equal to 7, p3 12, p4 19, then what is p5 equal to? Fine, you're given this is the given polynomial, and you are given that p1 is equal to 4, which can be written as 1 squared plus 3, and p2 is equal to 7, which is 2 squared plus 3. Similarly, P3 can be written, is equal to 12, that is equal to 3 squared plus 3. And P4 is equal to 19, that is equal to 4 squared plus 3. Now you have to find out P5. For that, let's say Px is equal to 2 into x minus 1, x minus 2, x minus 3, x minus 4, plus x squared plus 3. So you have P5 as 5 minus 1, 4, 3, 2, 1 plus 5 squared plus 3, which is equal to That's 8 and 6 plus 28, which is equal to 76. So this is the answer to the question. Option B is the correct answer. Hope you understood this. Next is question number 16. If the roots of this equation are in harmonic progression, then what is k? So you are given the equation as kx cube 18x square minus 36 x plus 8 is equal to 0. So if I transform x to 1 by x, then roots will be in AP. That means if I have k upon x cube 18 upon x square minus 36 upon x plus 8 is equal to 0, or you have 8x cube minus 36x square minus 18x plus k into 0, k is equal to 0. So now let's say roots are a minus t, a, and a plus t. So sum of the roots will be equal to, I'm adding all of that, so you will have 3a. 3a according to over here, this is equal to 36 upon 8, right? Yeah, so because that is equal to minus the coefficient of x squared upon the coefficient of x cubed. So this is equal to this. That means you have a is equal to 3 by 2. So root a is equal to 3 by 2 will satisfy the equation. Therefore, 8 into 3 by 2 whole cube minus 36 into 3 by 2 whole square minus 18 into 3 by 2 plus k is equal to 0. This will give me 3 cube, which is 27 minus 94, 9 into 3, that is again 27 minus 27 is equal to 0, plus k is equal to 0. These two will cancel, and there is a mistake. Actually, this is like 4, and this will cross 9. 9 nines are, this will be 81. Okay, so you will have k is equal to 81. This is the answer to the question. Option C is the correct answer. Hope you understood this. Next is question number 17. If alpha, beta, gamma are the roots of this equation, then match the list 1 with list 2. So, okay, let's start with that. The very first one. First of all, you are given equation x cube x square plus x plus 1 is equal to 0. This can be written as x square, I'm taking common, x plus 1 plus this. So the two roots will be x plus 1, x into x square minus 1 is equal to 0. So that means you can have x is equal to minus 1, or when x square plus 1 is equal to 0, which means x is square is equal to minus 1. That gives you x is equal to plus minus iota. So these are the three possible values for x, right? Now let's pick up the first option. That is 1 upon alpha, beta, and gamma. So three roots are this one. So this is 1 upon minus 1 plus 1 upon iota plus 1 upon minus iota. I'm taking the iota as the LCM. So here you will have minus iota. Actually, these will cancel, right? These will cancel. So no need to take the LCM and all that. You will have the minus 1 only. So this is equal to minus 1, and it matches with A. Okay, now the second one, a cube, alpha cube, beta cube, and gamma cube. Alpha cube, beta cube, and gamma cube. And we had the alpha is minus 1, beta as this, gamma as this. So basically they will again cancel, and you will have minus 1 as the answer again. So this again matches with A. Next is alpha raised to power 4, beta raised to power 4, gamma raised to power 4. Alpha, beta, and gamma raised to power 4. This is equal to minus 1 raised to power 4, iota raised to power 4 plus minus iota raised to power 4. This will be equal to 1, and this is again 1, and this is also equal to 1. So the answer is 3. And this is C and D. You are having both of them as 3. So you can pick up any one. I'm going with D. My shoes. Sorry, this is this one. Okay. Next is alpha minus beta whole square and that. So the fourth part is alpha minus beta square, beta minus gamma square, gamma minus alpha square. So this is minus 1 minus iota square plus 2 iota square plus minus iota plus 1 square. This is 1 and minus 1. Then it will be plus 2 iota plus 4 iota square. This will be 1 minus 1. Sorry, here is plus. So 1 minus 1 minus 2 iota. This and this will cancel, and this will cancel, and this will cancel. You will be left with iota square is equal to minus 1. So this is equal to minus 4. And this matches with option B. All right. So let's check with the options now, which is the correct one out of the given options. So 1, 2 with A, 3 with C or D, like it can be actually anything. I don't have 3 C with C any of these options, so it's okay. So, and you have the last one 4 at B. That means you have this option A is the correct answer to the question. I hope you got that. Next is question number 18. The number of odd numbers greater than 6 lakh that can be formed using these numbers without repetition is. So you're given the numbers as 0, 3, 6, 7, 8, and 9. So these are 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So that means I will have to start with this. 6 only. This number has to be occupied with a number 6 only. The rest can be had anyone. The number of odd numbers greater than this that can be formed by these digits. Okay, so next I can have a 7 over here, or 8 over here, or 9 over here, and question number 18, the number of odd numbers greater than 6 lakh that can be formed by these digits without repetition is. So you're given the digits 0, 3, 6, 7, 8, and 9. You want 6-digit number 1, 2, 3, 4, 5, 6. So see, you want the odd number, and you have two conditions. One is odd, and that the number should be greater than 6 lakh. So odd number can be done when you are having 3 over here, or 7 over here, or a 9 over here. So if you are having a 3 over here, then what can come in this place? You cannot have a 0 and 3 in this place. The C is already occupied. So that means you are left with 4 digits in this case. That is 6, 7, 8, and 9. So this can be filled up in 4 ways. And then you will be left with one will be occupied this, one will be occupied here. You'll be left with 4 digits. Now this can be filled up in 4 ways, 3 ways, 2, and 1. Similarly, see, when you're having a 7 over here, 3 is cut, 0 is cut, 7 is cut. So that means how many digits are left? 6, 8, and 9. This can be filled up in 3 ways. This can be filled up in 4 ways because 4 digits will be left. 3 ways, 2 ways, 1 way. Similarly, here you can fill it like when you're having 9 over here, this can occupy the place as 6, 7, and 8. So it can be filled up in 3 ways. Left will be 4 digits. So this place can be filled up in 4 ways. Now 3 digits will be left. Now 2 digits will be left, and 1 digit will be left. So the number of ways in this case will be 4 into 4 into 3 into 2 into 1, which is equal to 96. And this is equal to 3 into 4 into 3 into 2 into 1, which is equal to 72, and this is equal to 3 into 4 into 3 into 2 into 1, which is again 72 ways. Okay, so what are the total number of ways? Total ways will be 96 plus 72 plus 72, which is 240. So this is the answer to the question 240. Option B is the correct answer. Hope you understood this. Next is question number 19. Number of ways in which 6 men, 4 women can be seated around a table so that a particular man and a particular woman never sit adjacent to each other is. So you are having here 6 men and 4 women. 6 men and 4 women. Now arrangement of 5 men, because you have particular that one man and a particular woman cannot sit together. So you have to basically be conscious for arrangement of 5 men and 3 women around the table. So this can be done in 5 plus 3 minus 1 factorial into 8 will be the total one, C2 into 2 factorial. So because 2 gaps need to be 2 gaps needed out of available 8 gaps. Okay. So this is equal to 7 factorial into 8 into 7 upon 2 factorial into 2 factorial. This and this will cancel. So you will have a, this will be 8 factorial into 7. So 8 factorial into 7, this is option B. Hope you got this. Next is question number 21. There are 3 sections in a question paper, each section containing 4 questions. If a candidate has to answer only 5 questions from this paper without leaving any section, then the number of ways in which a candidate can make the choice of questions is. Okay, so in this question, we are having, see, there are 3 sections in the question paper. So this can be like, if I'm having section A, B, C, 1 question from A, 1 question from B, 3 questions from C, because you have to perform attempt any 5. So 1, 3, 1, another possibility, 3, 1, 1, another possibility. Okay, so this is equal to, like this can be done in 4C1, because the 4 questions in each section, 4C1 into 4C1 into 4C3, right? Now there are 3 such selections, so it will be multiplied by 3, right? This will give you 3 into 4 into 4 into 4, which is equal to 192, right? Now there's another thing. When you're having 3 sections, A, B, C, so you are attempting 1 question from here, 2 from here, 2 from here, or 2 from here, 2 from here, 1 from here, or 2 from here, 1 from here, and 2 from here. Again, the same thing, 4C1 multiply 4C2 multiply 4C2. This whole is multiplied by 3. Okay. So this will be equal to 3 into 4 into 6 into 6, which is 432. So what will be the total of it? This is 624. So that means you have here option A as your answer. Hope you understood this. Next is question number 21. The term independent of x in the expansion of this is. Let's write down the expression 1 minus 3x plus 2x cubed 3x square upon 2, 1 minus 3x raised to power 9. So the general term tr plus 1 is given by here 9cr. The first 3x square upon 2 raised to power n minus r, which is 9 minus r, minus 1 upon 3x raised to power r. So this is equal to NCR. I'm just segregating the 3x from here. So this will be 3 by 2, 9 minus r, minus this will be 1 upon 3. R, I'm just taking the x's out, all the x's I'm taking out. So this will be x raised to power. This will be, this was C. For this, it was x raised to power 18 minus 2r. And for this, it was x raised to power minus r. So this whole general term will become 9c r 3 by 2, 9 minus r minus 1 by 3 raised to power r, x raised to power 18 minus 3r. Now it is saying the term should be independent of x. So that means, see, you have to consider this expression also. That means x, for to be independent of x, that means it should be x raised to power 0. For that, there are 3 things. First of all, 18 minus 3r can be equal to 0. Or second thing, see, you are having 1x over here also. So that means 18 minus 3r, it should be inverse of this. So that means this should be equal to minus 1, or this should be equal to minus 3. Okay, so from here you have r is equal to 6. From here you have r is equal to 19 upon 3. And from here you have r is equal to 7. Right. So see, r is like it's not a rational number, the other integers. So that means you have r is equal to 6. Okay. So we get what we wanted in the question was the term. So that means you want this term to be like, it was expression. Let's write down the expression. It was 1 minus 3x plus 2x square into this. Right? So when I'm putting r is equal to 6, this will be equal to question number 21. The term independent of x in the expansion of this expression is. Let's write down the expression. You have 1 minus 3x plus 2x square multiply 3x square upon 2 minus 1 upon 3x raised to power 9. So the general term for this expression is given by tr plus 1 is equal to, here n is equal to 9. So this is equal to 9cr. First term 3 by 3x square by 2 raised to power 9 minus r raised to multiplied by minus 1 upon 3x raised to power r. So this is 9cr 3 by 2 9 minus r and 1 by 3 raised to power r. I'm segregating the 9x terms. So this is x square. This will give me x raised to power 18 minus r into x raised to power minus r. This will be 9cr 3 by 2, 9 minus r, 1 upon 3 raised to power r into x raised to power 18 minus 3r. Now let's use this whole expression which was given to you. That was 1 minus 3x plus 2x square into 3 by 2 x square minus 1 by 3x raised to power 9. This is equal to 1 3 by 2 x square minus 1 by 3x minus 3x 3 by 2 x square minus 1 by 3x raised to power 9 plus 2 x square. So this will be 2x square it is. Yeah. Just let me confirm. This is 2x cube, not square. So here it is cube, and here will be x cube. 3x square upon 2 minus 1 upon 3x raised to power 9. So now I want the terms independent of x. So for that here, in the very first one, you should have this thing only, because no x is involved here. So this 18 minus 3r should be equal to 0. And from here 18 minus 3r, it should be equal to, here is you are having x raised to power 1, so this should be equal to minus 1, then only they will cancel out. Similarly over here 18 minus 3r, this should be equal to minus 3. So from here you have r is equal to 6, r is equal to 19 by 3, which is actually not possible. And from here you have r is equal to 7. So I can't take this. This is not possible. Therefore, see over here, then we get 1 into t6 plus 1. And this is not possible. So plus 2x cube t 7 plus 1. This will give me 9c6 3x square upon 2 raised to power 3 minus 1 by 3x raised to power 6 plus 2x cube 9c7 3x square upon 2 raised to power 2 minus 1 by 3x raised to power 7. This is equal to 9 into 8 into 7 upon 3 into 2. And this is equal to 27 x raised to power 6 upon 8 multiply This is a power, so this will be 1 upon 27 into 27 into x raised to power 6. They will cancel, this will cancel this. And here you have 8 and 8 will cancel. So 3 this plus 2x cube 9c7, this is equal to 9 into 8 into 2 divided by 2 factorial. So this is it to 3 9x raised to power 4 upon this. So this is minus 1 upon 3 raised to power 7 into x raised to power 7. Okay, so first of all, these x's will cancel, and here is 3 raised to power 2, 3 raised to power 2, so 3 raised to power 4, and here you will be left with 3 raised to power 3. This 2 and 2 will also cancel. So ultimately you will be left in this portion as yeah, this will cancel like 9. So you have here 7 by 18 minus, this will go 2 by 27. This will be 54, will be the LCM, and 21 minus 4, which is 17 upon 54. This is the answer to the question, 17 upon 54. Option D is the correct answer. Hope you understood this. Next is question number 22. If summation from r is equal to 0 to 20, this whole thing, and GCD, that is the greatest common divisor of PQ, is equal to 1, what is P square minus Q square? Let's write down. So I'm expanding this now. This can be written as 20C0 plus 21C1, 22C2, so on till 40C20. This is equal to P upon Q, 40C20. So, okay. See, when I'm adding all of these, this is actually equal to 41C21 is equal to P upon Q 40C20, or 41 upon 21, 40C20 is equal to this. From here you compare, you get 41 is equal to, P is equal to 41 and Q is equal to 21. You have to find out P square minus Q square, which is equal to P plus Q into P minus Q, that is 41 plus 21, 41 minus 21. This is 62 into 20, which is 1240. So this is the answer to the question. Option C is the correct answer. Hope you understood this. Next is question number 23. If x is equal to 2 into 5 upon 2 factorial into 3 plus 2, 5, 7 divided by 3 factorial into 3 square, so on, what is the value for x square plus 8x plus 8? Okay, so here you have x square is equal to 2 into 5 upon 2 factorial into 3 plus 2 into 5 into 7, 3 factorial, 3 square plus 2, 5, 7, 9 divided by 4 factorial into 3 square, so on. So this gives me x by 2. Question number 23, if x is equal to 2 into 5 upon 2 factorial into 3 plus 2, 5, 7 upon 3 factorial into 3 square plus 2, 5, 7, 9 whole multiplication divided by 4 factorial into 3 cube till infinity, then what is the value for this expression? All right. So here, first of all, let's write down, you have x is equal to 2 into 5 upon 2 factorial into 3, 2 into 5 into 7 upon 3 factorial into 3 square, 2 into 5 into 7 into 9 upon 4 factorial into 3 cubed, so on till infinity. Let's do one thing. I will divide both the sides because I want to get rid of this 2. Divide both sides by 2 and multiply by 3. So you will have 3x upon 2 is equal to 3 into 5 upon 2 factorial into 3 3, 5, 7 upon 3 factorial into 3 square, 3, 5, 7, 9 upon 4 factorial into 3 cube till infinity. Now let's do dividing both sides by 3. Divide both sides by 3. You will have x by 2 is equal to, this will be 3 into 5 upon 2 factorial, 1 by 3 square, 3, 5, 7, 3 factorial, 1 by 3 cube, 3, 5, 7, 9 upon 4 factorial into 1 by 3, 4. It goes on till infinity. Now, I'm doing one more thing, that is adding 2 on both sides. Why I'm doing all this, you'll just come to know. Adding 2, which I'll write as 1 plus 1 on both the sides. Let's do. So you will have here x by 2 plus 1 is equal to 1 plus. Now the second one I'm splitting like how? 1 upon 1 factorial into 1 by 3, and here I will put a 3, right? So this is equal to 1 only, correct? This is raised to power 1 plus 3 into 5 upon 2 factorial, 1 by 3 square, 3, 5, 7, 3 factorial, 1 by 3 cube till infinity. Now, why I have done all this? Because I want to take it on the general, I want to compare it with the general equation. That is 1 minus x raised to power p upon q is equal to p upon 1 factorial into x upon q raised to power 1 plus p upon p into p plus q upon 2 factorial x upon q raised to power 2 p into p plus q p plus 2q divided by 3 factorial x upon 3 raised to power 3 till infinity. Okay, so if I'm comparing, this is the general equation, right? If I'm comparing these two equations, you surely have p as 3. So p is equal to 3 and x upon q is equal to 1 by 3. And this q is equal to, say, you are having a jump of 2 over here, 3. When I'm going from 3 to 5, I'm jumping 2 steps. So that means q is equal to 2. So from here, you have x is equal to 2 by 3, right? I got all the values, I suppose. Yeah, I got p is equal to 3, q is equal to 2, and x upon y is equal to this, which gives you x is equal to 2 by 3. Now, this is your LHS and this one is your RHS. LHS was x upon 2 plus 2 is equal to, RHS is given by, this is actually this thing, right? 1 minus x raised to power p minus q. So 1 minus x was 2 upon 3 raised to power minus p. P is 3 upon q is 2. So this is it. So that's equal to 1 by 3 raised to power minus 3 by 2. Or you have x by 2 is equal to, this will be 3 raised to power 3 by 2 minus 2, which is equal to 3 into 3 into 3 whole under the root. So this will be 3 root 2 minus 2. This is equal to x by 2, right? That means you have x as 2 into 3 root 3 minus 2. Correct? Now, let's get back. Where do you need to find out was x squared plus 8x plus 8. X squared plus 8x plus 8. So here you have 2. I'm taking 2 square as 4 outside. So this is 3 root 3 minus 2 square plus 16, 3 root 3 minus 2 plus 8. So this gives you 327 plus 4 minus 12 root 3 plus 48 root 3 minus 32 plus 8. This gives you 31. 31 fours are 124 minus 48 root 3 plus 48 root 3 minus 24. So here you have 100. This is the answer to the question. Option C is the correct answer. 100. That is option C. This is the correct answer to the question. Hope you understood this. Let's move to the next question, number 24. It says if the coefficient of x raised to power 4 in the expansion of this is m by n and modulus of m and n are co-prime, then what is the root of modulus of m plus n? Question number 24, if the coefficient of x raised to power 4 in the expansion of this expression is m by n, then and the mod of n and n are co-prime, you have to find out the value of this expression. You are given the expression as x upon x minus 1 square, x minus 2, which can be written as x into x minus 1 raised to power minus 2, x minus 2 raised to power minus 1. Now, x minus 1 raised to power minus 2, this can be written as, I'm applying the binomial theorem. So this is equal to 1 upon x square plus 2 upon x cube minus 3 upon x raised to power 4 plus 4 upon this minus 5 upon this, so on till infinity, whole multiplied by, and okay, not multiplied, fine. The second one, x minus 2 raised to power minus 1, this is equal to 1 upon x plus 2 upon x square plus 4 upon x cube, plus 8 upon x raised to power 4, so on till infinity. So this expression now becomes x into x minus 1 raised to power minus 2. This is equal to x into 1 upon x square plus 2 upon x cube minus 3 upon x raised to power 4, 4 upon x raised to power 5, so on till infinity. 1 upon x plus 2 upon x square plus 4 upon x cube, 8 upon x raised to power 4 till infinity. You had to find out in the question was coefficient of x raised to power 4, which is actually not possible because see, when you will be multiplying, this will be having x powers in the negative. That means to have x raised to power 4 coefficient, you need to have the mod of x to be positive. The power should be positive over here. Sorry, the power should be positive for x. Whereas in all these terms, when you will be solving, only negative powers of x are there. All right. So that means there is no possible solution for this answer, and simply no solution is possible. Next is question number 25. If sine raised to power 4x upon 2 plus cos raised to power 4x upon 3 is equal to 1 by 5, then what is the value for this expression? Okay, so you have a sine raised to power 4x upon 2. I'm breaking up cos raised to power 4x. This can be written as 1 minus sine square x whole raised to power 2, because this is actually equal to cos square x square. And the cos square x I can write like that. So let's 1 minus sine square x whole square upon 3 is equal to 1 by 5 sine raised to power 4 x upon 2 plus 1 plus sine raised to power 4 x minus 2 sine square x whole divided by 3 is equal to 1 by 5. Let's take the LCM and do the cross multiplication. So you have 3 sine raised to power 4x plus 2 sine raised to power 4x minus 4 sine square x is equal to 6, and 5 will be multiplied on this side. So you have 5 into 5 sine raised to power 4x minus 4 sine square x plus 2 is equal to 6, or 25 sine raised to power 4x minus 20 sine square x plus 4 is equal to 0, because plus done and 6 will come over here. So plus 4 is equal to 0. There's a perfect square for sine 5 sine square x minus 2 this. So that means you have sine square x as 2 by 5. If this is the case, then cos square x will be 1 minus sine square x. That means this is 3 by 5. Right now, what you have to find out is this. To find 27 secant raised to power 6 alpha plus 8 cosecant 6 alpha. That is this is 1 by cos square if I'm say replacing alpha by x, or you can say x by alpha actually. So this is cube plus 8 1 upon sine square alpha whole cube. This is cos square was 3 by 5, so this is 5 by 3 cube plus 8 into 5 by 2 cube. And here you have this is equal to, I'm taking the 5 cube common over here, and this 3 cube 27 upon 27 plus 8 upon 8, or you have this 125 into 2, or 250 is the answer. All right. That means you have option A as the correct answer. Hope you understood this. Next is question number 26. If tangent of beta is equal to this, then what is the value of tangent alpha plus beta into cot of alpha? Okay, let's write down. You having tangent beta is equal to n into sine alpha into cos alpha whole divided by 1 minus n cos square alpha. Here, tangent beta is equal to n tangent alpha. What I'm doing is dividing the numerator and the denominator by cos square alpha. So n into tangent alpha, and here you have secant square alpha minus n, which is equal to n tangent alpha. Secant square alpha can be written as 1 plus tangent square alpha minus n. So tangent alpha plus beta, you know, that is equal to tangent alpha plus tangent beta 1 minus tangent alpha into tangent beta. So that is, I'm writing this tangent alpha, and what was tangent beta? I will fill in n tangent alpha upon 1 plus tangent square alpha minus n whole divided by 1 minus tangent alpha into n tangent alpha upon 1 plus tangent alpha minus n. Hope this is clear till here. This further is equal to, yeah. So I'm taking the LCM. So tangent alpha plus tangent cube alpha minus n into tangent alpha plus n into tangent alpha. So these two will cancel. I'm not writing it down, okay? And here you have 1 plus tangent square alpha minus n into tangent square alpha. So tangent alpha plus beta, this is equal to, I'm taking the tangent, these two will cancel. I'm taking tangent alpha common, 1 plus tangent square alpha whole divided by 1 minus, there will be two factors. See, this particular thing can be written as 1 plus tangent square alpha minus n, 1 plus tangent square alpha. So this is 1 minus n into 1 plus tangent square alpha, which is equal to tangent alpha upon 1 minus n. Now you have to find out tangent alpha plus beta into cot of alpha, which is equal to tangent alpha 1 minus n into cot alpha. You know they are reciprocals. So this is equal to 1 upon 1 minus n. Okay. But I don't have 1 upon n minus 1 in the options, but this can be written as minus 1 upon n minus 1. Okay. So that makes option A as the correct answer. Hope you got that. Next is question number 27. Cos A plus cos B plus cos C is equal to 0 is equal to sin A plus sin B plus sin C. You have to find out this value. This is pretty easy question actually. Hope you can do it very easily and like piece of cake for you. So you have a cos A plus cos B plus cos C is equal to 0. Also you have sin A, B, C is equal to 0. Let's square them, both of them, squaring and adding them. So you have cos square alpha plus, from here you have sin square A and cos square b, sine square b, cos square c, sine square, not plus, wait. Sine square c plus. Now, you have, you know the formula, right? A plus b plus c whole square is equal to a square plus b square plus c square, which I have done. A square plus b square plus c square in both the cases, plus 2ab plus 2bc plus 2ca. So this is 2 into sine a cos a. Question 27. If cos A plus cos B plus cos C is equal to 0 is equal to sin A plus sin B plus sin C, then what is the value for cos A minus B plus cos B minus C plus cos C minus A? Okay, so you have two things with the U, that is cos A plus cos B plus cos C is equal to 0. Also, you have sin A plus B plus C is equal to 0. Sin C is equal to 0. Let's do squaring both of them and adding. So squaring and adding them. What you will get is cos square A plus C. I'm squaring it, okay? So this is cos square A plus cos square B plus cos square C plus 2 cos A cos B 2 cos B cos C to cos A cos C. Similarly, you have sine square A, sine square B, sine square C to sine A, sine B, sine B, sine C, sine A, sine C. You know, this is equal to 1, this is equal to 1, this is equal to 1. Okay, this is equal to 0. Okay. So you have 1 plus 1 plus 1, that is equal to 3 plus 2 cos A plus B plus 2 sine A plus B. I'm taking the 2 common. So here you have cos A, cos B plus sine A, sine B, 2 cos B cos C plus sine B sine C. Here is plus 2 cos A cos C sine A sine C is equal to 0. I'm taking 2 common from all of these. You know, cos A cos B plus sine A sine B, this is equal to cos A minus B, B minus C. And in the question, I'm having C minus A, right? So I will write down better to C minus A only. Okay, you can write A minus A or C minus A because you know that cos of minus X is equal to cos of X. So no problem in that. Now this whole thing was equal to 0. So this gives you cos A minus B, B minus C, C minus A is equal to minus 3 by 2. Right, that's the answer to the question, minus 3 by 2. This is option D. So here we have option D as the answer. Hope you understood this. Next is question number 28. Is sine x into cos hy is equal to cos theta and cos x into sine hy is equal to sine theta. What is the value for sine square x plus cos h square y? Okay, let's write down these two things. You have a sine x cos hy is equal to cos theta, also cos x sine hy is equal to sine theta. Now again squaring and adding them. You will get sine square x cos h square y cos square x Sin h square y is equal to this, and you know this is equal to 1. So this is the formula for mm, I'll do one thing. I'll sin square x cos h square y plus sin h square y plus, see, I'm splitting this cos square into 1 minus sin square x. Okay, so this can be written as 1 minus, not plus. Here will be minus sin h square minus sin square x into sin h square y. So let's take sin square x common from all of them. You will have cos h square y minus sin h square y plus this. So this is equal to sin square x. You know this is equal to 1. So plus, I'll convert this. So you know this is equal to 1. So this can be written as cos h square y minus 1 is equal to 1. This gives you sin square x plus cos h square y is equal to 2. So that's it. You have option B as the answer. Hope you understood this. Next is question number 29. If in a triangle ABC are in the arithmetic progression and A is equal to 2C, what is the ratio between B and C then? We are given that these three are in AP, which means 2B is equal to AC. Also, you are given that A is equal to 2C. So these are the three angles. Also, you know that A plus B plus C is equal to pi. Is equal to pi. So you have 2C plus B plus C is equal to pi, or you have B is equal to pi minus 3C. Correct? Okay. Now from the sine rule, you have a 2 sine B is equal to sine A plus sine C. This is by the sine rule. So 2 sine B, sine A is equal to sine 2C plus sine C, or you have 2, I'm getting everything in terms of C. So this is 2 sine pi minus 3C is equal to 2 sine C cos C plus sine C. So this is 2. This can be written as 3 sine C minus 4 sine cube C is equal to sine C. I'm taking common 2 cos C plus 1. Okay, so this is equal to 6 sine C minus, see, I'll do one thing. I'll take the sine C common from this side also. 2 sine C, there will be 3 minus 4 sine square C is equal to sine C 2 cos C plus 1. So sine C and sine C will cancel. Ultimately, you will have 6 minus 8 sine square C is equal to 2 cos C plus 1, or 6 minus 8 into 1 minus cos square C is equal to this, or you have 8 cos square C minus 2 cos C minus 3 is equal to 0. Let's spread the middle term because this is a quadratic equation types. So you will have the two factors. Okay, let's solve it. Let's say cos C is equal to T. So this will be 8T square minus 2T minus 3 is equal to 0. So I'm applying the quadratic formula. That means T will be equal to minus B, which is 2 plus minus 4 minus 4AC. So 4 into minus 3 into 8, and that is 96. So here is plus 96 divided by 16. So you will have 2 plus minus 100 root 10 upon 16. That means you can have 12 upon 16 or minus 8 upon 16. That gives you the answer as 3 by 4 or minus 1 by 2. So these are the two possible options for cos C. And what I have to get in the question is B ratio C. Let's go for that. So B ratio C, that is equal to sine B upon sine C. And sine B is equal to pi minus 3C. That can be written as sine 3C itself. And I'll let the sine C to be sine C, which is equal to 3 minus 4 sine square C, which is 4 cos square C minus 1. Hope you understood this. Like 3 sine 3C is actually 3 sine C minus 4 sine cube C. And when I've taken sine C common from here, this will be 3 minus 4 sine square C. And here I have converted sine square C into 1 minus cos square C. Okay, so I got to this one. Now you had the two values for cos C. That was 3 by 4 and minus 1 by 2. So B upon C for cos C is equal to 3 by 4. You have this is equal to 4 into 3 by 4 into 3 by 4 minus 1, which is equal to 9 by 4 minus 1, which is 5 by 4. And for cos C is equal to minus 1 by 2, you have B by C is equal to 4 into minus 1 by 2 minus 1, which is sorry, minus 1 by 2 into minus 1 by 2. So these two will cancel and you will have 1 minus 1 that is equal to 0. So these are the two possible values. That is, okay, 0 is not in the option, but we have 5 ratio 4 in the option. So that means option C is the correct answer. See, you had the two values for B ratio C. Here is 5 is to 4 and here the B ratio C is equal to 0. So hope you understood this. Let's move to the next question. Question number 30, assertion in a triangle ABC, if this r small r is equal to 6, r2 is equal to 36, and capital R is 15, then c square plus a square is equal to b square, which reminds me of the Pythagoras theorem. And the reason for the same is in a triangle, if the ratio of in radius, circumradius, and one of the x radii is 1 is to 2.5 is to 6, then b is equal to 90 degree. That means again it's a right angle triangle. 31, if B, C are unit vectors such that A is perpendicular to both B and C. An angle between B and C is 2 pi by 3. Then what is the value for this expression? You're given A, B, C are 3 unit vectors. That means their magnitude is 1. Also, A is perpendicular to B and C both. That means their dot product is equal to 0. Right? 1 minute. A is perpendicular to both B and C, and angle between B and C is 2 pi, 2 pi by 3. That means B dot C is equal to cos of 2 pi by 3, which is equal to minus 1 by 2. You have to find out A plus 3B minus 4. C vector magnitude square, which is equal to A square plus 9b square plus 16c square plus 6 a dot b. It will be 24b dot c minus 8 c dot a, which is equal to 1 plus 9 plus 16. This is 0. This is minus 24 minus this minus 0. The total will be equal to 38. That is option C. Hope you understood this. Next is question number 32. Let A be this vector, be the position vector of a point A. Let B be this vector and C be this vector, be the two vectors, and R be a vector passing through the point A and parallel to the vector B. If the projection of R on C is 9 by root of 6, what is the magnitude of R vector? Okay, so first thing, let's say the R vector is A plus lambda B. Yeah. So we are given projection of R on C is equal to 9 root of 6. Since r dot c is this, therefore that means r dot c upon the magnitude of c is equal to this. Correct? So simply means a dot c plus lambda b dot c divided by root of 1 plus 1 plus 4 is equal to this, which gives you a dot c. Okay, let's write down. You have the a vector as this and c vector as this, 2i minus j plus k. So 2i minus j plus k and c vector was equal to I plus j minus 2k. Okay. All right. So here that means 2 into 1. This is equal to 2 minus 1 plus minus 2. 2 minus 1 minus 2 plus lambda b dot c. What is the b vector? Let's write on that as well. I plus 2j minus k. So this is equal to 1 and plus 2 plus 2. Whole divided by the magnitude of this is 6. This is equal to 9 by root of 6. They will cancel out and you'll be left with this is minus 1 plus 5 lambda is equal to 9 or lambda is equal to 2. Right. And what we had to make our vector was equal to a plus lambda b. It was a plus lambda b. So this is equal to a plus 2b. So that makes what is the a vector? 2i minus j plus k and b. Like I'm multiplying by 2, 2i plus 4j minus 2k, which is 4i plus 3j minus k. So this is the vector 4i plus 3j minus k. You have to find out the magnitude of this R vector, which is given to us 4 square 16 plus 3 square 9 plus 1, which is equal to root of 26. So you have option A as the answer. Hope you understood this. Next is question number 33. So there is a match problem over here. S is the circumcenter. O is the orthocenter, S is the circumcenter, G is the centroid of the triangle ABC. Then match the items of list 1 with those of list 2. Okay, so here O is the orthocenter, S is the circumcenter, G is the centroid of the triangle ABC. That means let's say OA is equal to A vector, OB is B vector, and OC is C vector. Then OG is given by A plus B plus C upon 3 and OG is equal to 2 into OS minus 1 into O upon 2 plus 1. This gives you 2 OS upon 3 or OS is equal to 3 by 2 OG. That means this is 3 by 2 into A plus B plus C upon 2, right? Yeah, upon 3, sorry. Okay, so this and this will cancel. So you will have A plus B plus C upon 2. This is equal to OS. Now, OA plus OB plus OC is A plus B plus C. That means 2A plus B plus C upon 2 is equal to nothing but 2 AS, OS. So SA plus SB plus SC is OA minus OS, OB minus OS, OC minus OS, which is this minus 3, wait, minus 3 OS. So you have here, see, this is equal to 2 OS minus 3 OS, which gives you minus OS. And these are all the vectors. So minus OS can be written as vector SO. Also, GA plus GB plus GC is equal to OA minus OG plus this plus this, which is equal to A plus B plus C minus 3 OG, that is A plus B plus C minus 3, A plus B plus C on 3, which is equal to 0. Now let's go to match the options. First of all, SA plus SB plus SC, this is equal to SO. That means this matches with the option D. This is first part. Then GA plus GB plus GC. Here it is. GA plus GB plus GC. This is equal to 0. So that makes it second one. OA plus OB plus OC, which is actually equal to A plus B plus C, which is nothing but 2 OS. So here is part 3. And OG is equal to 2 OS upon 3. That means you have here. This is option 4. So looking at these, you will get that option D is the correct answer. Hope you understood this. Next is question number 34. Let A, B, C be 3 vectors such that A dot A is equal to B dot B is equal to C and C is equal to 5. And the magnitude of this square plus this is equal to 50. Then you have to find out A dot B plus B dot C plus C dot A vector. Okay. So first thing, you know this, the dot product of these two, the same vectors is equal to their magnitude square, and you are given this is equal to C, which is equal to 5. Similarly, B dot B is equal to this is equal to 5. C dot C is equal to this is equal to 5. Now, A plus B minus C square plus B plus C minus A square plus this. When you will open, you will get this as 3 magnitude of A square, this and this. And also this is it. And then you will be having, see, this is, I'm applying the formula minus 2AB to BC to CA. So according to that, this will be A dot B, B dot C, C dot A. Now you are given in the question that this is equal to 50. So here it makes A dot B. So this is actually 5 plus 5 plus 5 minus 2 into A dot B, B dot C, C dot A is equal to 50. So here you have 30 and this will be minus 2. This is equal to 20. We'll be left here with 20. So that makes here as sorry, this is a mistake, and this is 15 3s are 45, so you'll be left here with 5, okay? And this 2 will not cancel. I'm rewriting this line, minus 2 A dot B, B dot C, C dot A is equal to 5, which gives you A dot B, B dot C, C dot A is equal to minus 5 by 2. So this is the answer to the question. Option B is the correct answer. Hope you understood this. Next is question number 35. So let's see be the vector coplanar with the unit vectors A, B, and let be the unit vector perpendicular to A, B, C. If AABD is equal to I plus 2J plus 2K, then the angle between A and B and the angle between A and B is 30. You have to find out the magnitude of C vector. All right, so here you are given, let's see with the vector coplanar with AB. So that means ABC, they are coplanar. Which means this is 0. Now, this is 0. Okay. A, P, D. Yeah, A, B, D, C minus this you're given is equal to I plus 2J plus 2K. And this is 0. So that gives you A, B, D, C is equal to I plus 2J plus 2K, which in turn is A cross B dot D C is equal to I plus 2J plus 2K. So that means C is equal to 1 plus 4 divided by A cross B dot D, which is equal to 3 upon this. So that's it. Okay, sorry, one more thing you are given that the angle between A and B is 30 degrees. So this is equal to 3 upon this, which is equal to 3 divided by this. And the answer is 6. So that's it. You have option C as your answer. Hope you understood this. Next is question number 36. The mean and standard deviation of 100 observations were calculated as 40 and 5.1 respectively. Later on, it was found that one of the observations was taken as 50 in place of 40. If the wrong entry is replaced by the correct one, then the sum of square of all the observations is. Okay, so first of all, you are given that the mean and the standard deviation is this and this. So mean is 40. That means the total of all the observations. Total of all the observations is equal to the mean into the number of observations, that is 100, which is equal to 4,000. Also, you are given standard deviation is equal to 5.1. So you know that thing that the standard deviation is equal to sigma xi square upon the sum of frequency, that is 100 in this case, minus mean square. So 5.1 square is equal to summation xi square upon 100 minus 1600, or summation xi square is equal to, you will have 100 into 26.01, because the square of 5.1 is this, plus 1600, which is equal to 162,601. Now, after correcting, 50 by 40, you will have the correct sum of the squares as 12601 minus 50 square plus 40 square, because this is the wrong one and this is the right one. So this will be 161701. So you have option D as your answer. Hope you understood this. Next is question number 37. If a matrix is chosen at random from the set of 3 by 3 non-zero matrices whose entries are the elements of the set -101, then the probability that the matrix is skew symmetric is. Okay. So total 3 by 3 matrix using this. They are equal to 3 into 3 raised to power 9, which is equal to 19683. Also, total 3 by 3 non-zero matrix. because there is one possibility. So this will be equal to -1, which is equal to 19682. Now, skew symmetric matrices. Skew symmetric matrices. You have A11 is equal to A22, A33 is equal to 0, A1, A12, A13, A23 can be filled in 27 ways, but all can't be 0. So 27 minus 1, 26 ways. So the required probability is number of favorable upon the number of total cases, which is equal to this. So this is the answer to the question. Option B is the correct answer. Hope you understood this. Next question number 38. A boy throws an unbiased die. Whenever he gets 1 on the die, he has a further chance to throw it once again immediately. The probability that the boy gets a score of 7 in this process is... Okay, so you have first throw. Question number 39. There are 10 coins in a box, out of which 8 are normal and the remaining have head on both the sides. Coin is chosen at random from the box and tossed 6 times. If it shows head on each time, then the probability that the selected coin has head on both the sides is... Fine. So you have 10 coins, out of which 8 are normal and 2 coins are biased. So the probability of getting, probability that the selected coin has both the sides head, that means biased coins, probability biased coins in which both only head appear. Okay, this is given by probability biased coin intersection appeared head divided by probability that a head appears. Okay. Now this is given by probability biased coin. There are 2 biased coins out of 10 and appear head. On a biased coin, you have 2 heads. So 2 by 2 is 2 by 6 whole divided by, you have 2 biased coins out of 10 multiplied 2 by 2 raised to power 6, 8 biased coins, 8 normal coins out of 10 multiply 1. So out of 2, you have only 1 head raised to power 6. So this gives me, on solving, 2 upon 2 plus 8 into this. So this is equal to 2 into 8 upon 16 plus 1, which is equal to 16 upon 17. So this is the answer to the question. Option A is the correct answer. Hope you understood this. Let's move to the next question. Question number 40. A random variable x has the following distribution. X is equal to xi, which is given by -2, -1, 0, 1, 2, 3. And the probability x is equal to xi is given by these values. Now you have to show then the variance of this distribution is... All right. You know one thing, that the sum of the probability or total probability is equal to 1. You know that, which means the sum of all of them is equal to 1. That means 0.1 plus k plus 0.2 plus 2k plus 3k plus k is equal to 1, which means 7k plus 0.3 is equal to 1, or 7k is equal to 0.7, which gives me k is equal to 0.1. Now the variance square is given by summation x square px minus summation x into px whole square, which is equal to summation x square px is equal to 4 into 4 into 0.1 plus this is equal to 1 into k plus 0 into 0.02 plus 1 square into 2k plus 4 into 3k, 9 into k. And we already calculated k is equal to 0.1. So this is equal to 0.4 plus 0.1 plus 0.2 plus that's equal to 12, and this is 1.2, and this is equal to 0.9, which will give you a total of 2.8. Yeah, yes, it is it. So this is 2.8. Also submission x px, this is equal to, let's see, this is equal to minus 0.2, 0.1 plus 0 plus 0.2, 0.6 plus 0.3. See, I hope you know this. I'm multiplying them. Okay, all of them. So this gives me a total of 0.8. So that means the variance square is equal to 2.8 minus 0.8, which is 0.8 square, which is equal to 2.8 minus 0.64, which is equal to 2.16. So this is the answer to the question. Option C is the correct answer. Hope you understood this. Let's move to the next question. Question number 41, a straight line passing through the fixed point minus 3, 4 intersects the coordinate axes at A and B. If O is the origin and OABC forms a rectangle, then the locus of C is. Here you have the coordinate axis, and this is the one. And let's say this is the point minus 3 and 4. So let's say this point is about here. And this, a straight line which is passing through this 3 minus 3 comma 4 point, it cuts the coordinate axis at the point A and B. So let's say this is the point C, because OA, first of all, there's a bit of mistake, because OABC cannot be any rectangle. It can be OACB. The only possible rectangle is. Now let's say the coordinates of C, R, H, and K. What will be the coordinates of B? It will be 0, comma K, and the A will have the coordinates minus H, comma 0. And of course, the origin is going to have 0, comma 0. Now, the intercept form says x plus x upon A plus y upon B is equal to 1. So now let's say the coordinates of CB, H upon K. So it will be given by x upon H plus y, actually minus H upon, in this case, this is minus H, and y upon K is equal to 1. Now, further you have at the point minus 3 and 4. For this point, you have this as minus 3 upon a minus H plus y upon, sorry, this is 4 upon K is equal to 1, which gives you 3. I am interchanging H with X and K with Y. So this will be 3y plus 4x is equal to xy, or xy minus 3y minus 4x is equal to 0, which is actually no options. There is 3x 4y. In other case, we are having 3y 4x. So no option is available for the answer. Hope you got that. Next is question number 42. When the origin is shifted to the point P by the translation of the x's, this is transformed to this equation. Then the transformed equation of the straight line, this, if the origin is shifted to the same point P, is, all right. So here you have the equation as 2x squared plus y squared minus 4x plus 4y is equal to 0. I'm taking 2 common. Also, see, this is 2x squared, and all right, I'm taking there 2 common, so this will be x squared minus 2x. I'm adding a 1 over here. Similarly, y squared plus 4y, I'm adding a 2 over here. Correct? So this is 2 plus 2. Okay. Sorry, this is 4. It should be 4. So 4 plus this, I'm adding a 6 over here. Adding 6 on both sides. 2 I have utilized over here, and 4 I have utilized over here. Now, let origin be shifted to O dash H comma K. So new equation will be given by 2x minus h minus 1 square y minus k plus 2 square is equal to 6. Let's say this is equation 1, which is given as 2x square plus y square minus 8x plus 8y plus 18 is equal to 0. Or again, I'm making it perfect square form. So taking 2 common, you have x square minus 4x. So I'm adding 4 over here. Similarly, y square plus 8y plus this is 16. So I'm adding this will be 8 plus 16, which is 24. 18 is already there, so I have to just adjust to 6. So this is equal to 6. Let's say this is equation 2. On comparing 1 and 2, comparing 1 and 2, you will get h plus 1 is equal to 2 and k minus 2 is equal to minus 4, which gives you h is equal to 1 and k is equal to minus 2. Therefore, the equation of the line will be x plus 2y plus 2 is equal to 0. This equation will be now x minus 1 to y plus 2 is equal to 0, which is x plus 2y plus 5 is equal to 0. So that makes option D to be the correct answer for the question. Hope you understood this. Next, question number 43. If the circumcenter of the triangle formed by the points A, B, C is 1, 1, then out of the possible coordinates of C, the sum of the absolute values of the distinct coordinates of C is. So you're having A as this, B comma 5, and C as A comma B. So this is having circumcenter is 1, 1. Circumcenter is 1, comma 1. Now we know that OA square is equal to OB square is equal to OC square. That means A minus 1 square, 3 minus 1 square is equal to B minus 1 square plus 5 minus 1 square. This is 1 and 2. So this is equal to A minus 1 square plus B minus 1 square. This is 3. Now equating 2 and 3. Equating 2 and 3, you will get A minus 1 square is equal to 16, which gives you A minus 1 is equal to plus minus 4. That means A can be equal to 5 or minus 3. These are the two possible values. Now equating 1 and 3. So if I'm equating them, you will have B minus 1 square is equal to 2 square, which is equal to 4, or you have B minus 1 is equal to plus minus 2, which gives you the two values for B as 3 and minus 1. So therefore, sum of absolute distinct values is 5 plus 3 plus 1, that is equal to 9. So here you have option B is the correct answer. Hope you got that. Let's move to the next question, number 44. If the lines this, and this are congruent, then what is the value for K? You know, when the lines are congruent, their determinant is equal to 0. So these are the three equations. Kx plus 2y plus 1 is equal to 0. 4x plus 2ky plus 7 is equal to 0. Let's write them in determinant form. So this is 1, 1 minus 1. This is k, 2, 1, 4, 2, k, 7. So this determinant is equal to 0 if they are congruent. Okay, let's find out determinant now. So this is 1 into 14 minus 2k minus 1, 7, k minus 4 minus 1, 2k square minus 8 is equal to 0. This gives me 2k square minus 9k plus 26 is equal to 0, or 2k square plus 9k minus 26 is equal to 0, which gives me the two values for k as minus 13 by 2 and 2. All right. But when I'm putting k is equal to 2, line x plus y minus 1 is equal to 0. These three lines and this, it was plus 7. These lines are parallel. Why? Because see, here the ratio is same. This is like if I multiply this equation by 2, or you can simply say the ratio of your here is 1 by 2 ratio for x and y. And similarly, here is also the ratio same 1 by 2. So that means these three lines are parallel, because I hope you remember the formula for that, that A1 upon A2, sorry, A1 upon B1 is equal to A2 upon B2. When the ratios are same, then the lines are parallel. So these lines will become parallel. But I want the lines to be congruent. That means K is equal to minus 13 upon 2. This is the answer to the question. Option C is the correct answer. Hope you understood this. Let's move to the next question. 45. If alpha, beta, where alpha is greater than beta, the two values of K such that these equations, this and this, represent two perpendicular lines, then what is the value for alpha square plus 2 beta? Students, before starting with the questions, a quick reminder to visit our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers. Also download our app for a better preparation of your exams. Now let's start with the question. You are given the two equations as 2x plus 3 minus 2ky plus 2k plus 1 is equal to 0, and the second one kx plus k minus 1 into y minus 4 is equal to 0. You know, for the two perpendicular lines, the product of their slopes is equal to minus 1. For the first line, the slope is given by, before starting the slope, let's rewrite this. This is equal to minus 2x minus 2k plus 1, or y is equal to minus 2 upon 3 minus 2k x minus 2k plus 1 upon 3 minus 2k, right? So from here, the slope is equal to minus 2 upon 3 minus 2k. And from here, you have k minus 1, y is equal to minus kx plus 4, or y is equal to minus kx upon k minus 1 plus 4 upon k minus 1. The second slope is minus k upon k minus 1. Right, now, according to the question, these lines are perpendicular, which means the product of their slope is equal to minus 1. That means multiplying this with this, you have 2k divided by 3 minus 2k, k minus 1 is equal to minus 1. That gives you 2k is equal to 2k minus 3, k minus 1, which is equal to 2k square minus 2k minus 3k plus 3, this. So you have 2k minus 7k plus 3 is equal to 0. So the two, you have to find out two such numbers. The sum should be minus 7, the product should be 6. So these are the numbers. K plus 3 minus 1. Sorry, here is minus 3. So you have here 2k minus 1, k minus 3 is equal to 0, k is equal to these two possible values for k. So next is you were given that alpha and beta two values of k. So that means these are the two values of k, correct? You have to find out alpha square plus 2 beta. So let's say alpha is equal to, wait, we are given that alpha is greater than beta, right? So that means alpha is equal to 3 and beta is equal to 1 by 2. Right, and you have to find out alpha square plus 2 beta, which gives you, sorry, 3 square plus 2 into 1 by 2, which is equal to 10. So this is the answer to the question. Option D is the correct answer. Hope you understood this. Next is question number 46. So here you have a, if k is equal to a plus b upon ab is a non-zero constant, then the point which lies on this straight line is, fine. So k is equal to a plus b upon ab. That makes k as 1 upon b plus 1 upon a, or better to write 1 upon a plus 1 upon b. Let's write it again. This is the 1, right? So that means 1 upon Ka plus 1 upon Kb is equal to 1. Let's compare it with the given equation. X upon A, Y upon B is equal to 1. To have the equation verified, we need to have the equation verified. We need here x is equal to 1 upon k and y is equal to this. Therefore, the point becomes 1 upon k, 1 upon k. That is option D. So this is the correct answer to the question. Hope you understood this. Let's move to the next question, number 47. The point of congruence of all the chords this which subtend a right angle at the origin is. Okay, you are given the equation as 3x square minus y square minus 2x plus 4y is equal to 0. Let the chord be ax plus by is equal to 1. Let's say this is 1 and 2. Now making homogeneous to equation 1 with the help of equation 2. Making homogeneous to equation 1 with equation 2. You have 3x square minus this ax plus by plus 4y ax plus by is equal to 0, or 3 minus 2a x square 4b minus 1 y square minus 2b xy 4 axy is equal to 0. Now chord subtracts right angle, chord subtend right angle at the origin. So chord subtend right angle at the origin. Therefore, the coefficient of x square and y square will be 0. That means 3 minus 2a, 4 minus 4b minus 1 is equal to 0. Or you have here minus 2a plus 4b plus 2 is equal to 0, or a minus 2b minus 1 is equal to 0, which gives you a minus 2b is equal to 1. Now let's compare it with, on comparing with ax plus by is equal to 1, you have we get this fixed point as, we get the fixed point as 1 minus 2 from here, right? So this is the answer to the question, 1 minus 2, option B. This is the answer to the question. Hope you understood this. Next is 48th question, the equation of the circle which is passing through this and touching both the coordinate axes. See, it is passing through this point, right? So this is touching both the coordinate axes. So the circle is somewhat like this. Okay, it's not up to the mark, but the circle is this. Equation of the circle passing through this. So the circle is passing through, let's say this is let's say this is minus 6 comma 3. Okay, so it is touching the x-axis and this is the center. Let's say this is minus a comma a. Okay, so let's say radius is equal to a. So the center will be given by minus a comma a. Now equation of the circle will be given by x minus a square, sorry, x plus a square, because it is minus minus plus, right? And y minus a square is equal to a square. Let's open. You have x square plus a square plus 2ax y square plus this minus 2ay is equal to a square. So this will cancel and you have x square plus y square plus 2ax minus 2ay plus a square is equal to 0. Now this circle passes through this point. At this point, let's fill in this equation. You have 36 plus 9 plus minus 12x. Sorry. This will be minus 6a plus a square is equal to 0. So the quadratic equation a square minus 18a, this, and you know the two numbers will be 15a minus 3a plus 45 is equal to 0. A minus 15 minus 3a minus 15a minus 3. So the two values for a will be equal to 5 or 13. Yeah, sorry, 3 or 15, right? Now, equation of circle will be x squared plus y squared plus 30x minus 30y plus 5 is equal to 0, or this can be written as x squared plus y squared plus 6x minus 6y plus 9 is equal to 0. These are the two possibilities, right? Let's check out of these which you have in the options. We have here option C as the correct answer. Hope you understood this. So yeah, let's move to the next question, number 49. The area and square units are triangle formed by x-axis, tangent, and the normal drawn to this circle at this point is, let's make the figure first. So here you have the coordinate axis and circle is this formed by the triangle by the x-axis, tangent and normal to the circle. So this is the circle's equation, x square plus y square minus 10x is equal to 0. From here you have the center as minus half the coefficient of x, which is 5 and 0. So this is the center of the circle, 5 comma 0. So center of the circle lies on the x-axis. Okay, this is the circle. So radius of the circle is also 5 units. Now tangent is drawn at 9 comma 3. So yeah, tangent is drawn at this point. This is 9x plus 3y minus 5 into x plus 9 is equal to 0, which is 4x plus 3y is equal to 45. Now normal at the point 9 comma 3 will be given by 3x minus 4y is equal to lambda, which gives you 3 into 9 minus 4 into 3 is equal to lambda, or on solving you will get lambda is equal to 15, which means 3x minus 4y is equal to 15. Now let's see the triangle which is being formed. So triangle formed by the x-axis, the tangent, and the normal drawn to the circle at the point 9 comma 3. Let's see, this is the point P 9 comma 3. So this is the tangent which is drawn at this point. This is the tangent and it is actually passing, right? So it is outside this and normal. So here, right? So basically you have to find out this area. Okay, now area of the triangle is half into base, which is question number 49. The area square units of the triangle formed by x-axis, tangent, and normal drawn to this circle at the point 9, 3 is. Let's see how the circle looks like. So this is your coordinate axis. This is your x and the y axis over here. And this is the equation of the circle x squared plus y squared minus 10x is equal to 0. You know the center is given by minus g minus f. G is half the coefficient of x. So center is equal to 5 comma and f is missing over here. So this is the center 5 comma 0. That means this is the center. So here we have the circle with the center on the x-axis. This is the circle, right? Now there's a point. Let's say this is the point 9 comma 3. Let's say this is point P. And let's make a tangent at this point. So this is a tangent and this is the normal. So here you have to find out area of this triangle. Let's say this is point A and this is point C. Okay, fine. So here the tangent is at point 9 comma 3. Equation of tangent at the given point is given by this. The general formula is x is into x1 y1 plus g x plus x1 f y plus y1 plus c is equal to 0. So here you have the point is 9 comma 3. So this is x1 and y1. This will be 9x plus 3y plus g is minus 5. This is x plus 9 plus 0 is equal to 9. So here you have 9x minus 5x plus 3y minus 45 is equal to 0, or you have 4x plus 3y is equal to 45. This is the equation of the tangent. And let's find out the coordinates of A point. A has the, for finding out the coordinates of A, let's say this is A comma 0. So this can be given by a point of intersection of the x-axis and the tangent. So this A point is the point of intersection of tangent and x-axis. So this is given by, I'm putting an x-axis, y is equal to 0. So this is 4x plus 3 into 0 is equal to 45, or x is equal to 45 upon 4. Therefore, a point becomes 45 upon 4, comma 0. This is point A, and now let's find out what is the length of CA. CA will be 45 minus 4 minus 5. Area of the triangle. What was the triangle name? It was PAC. This is half into base into height. So this is half into CA into height is, you have to draw perpendicular over here. Let us say this is point D into DP. Okay, DP is what? DP is 3 units, because this is over here, the point D. This is having like DP is equal to 3 units, because here the y coordinate is equal to 3. And CA we already calculated. This is 45 by 4 minus 3 into 3. So that makes it half into, this is 45 minus 12, which is 33 upon 4 into 3. And here you have 99 upon 8. Wait, there is a small mistake. It was 5 and I have written 3 over here. So this is 45 minus 20. So I'll redo this from here. That's equal to half into 45 by 4 minus 5 into 3, which is half into 45 minus 20, which is 25 upon 4 into 3, that is 75 upon 8 square units. So you have option B as your answer. Hope you understood this. Next is question number 50. The number of common tangents to this and this circle is which of these options? So here you have two circles which are given by x square plus y square minus 4 is equal to 0. And the second one is x square plus y square minus 6x minus 8y minus 24 is equal to 0. Let's make the perfect squares out of it. So this will be x minus 3 square, y minus 4 square. So here I'm adding a 9, here I'm adding a 16. 9 and 16, that gives you 25 and is minus 24. So that means this will be, I'm adding this 25. So subtracting 25 now. Minus 25 minus 24 is equal to 0. So the equation of the circle is x minus 3 square, y minus 4 square is equal to 49. Let's write it down. X square, sorry. So this is equal to x minus 3 square, y minus 4 square is equal to 49. Here in this, the center is given by 0, 0, that's origin. And here the center is given by 3, 4. And also the radius 1 in this case. So radius 1 is equal to this root of 4, which is equal to 2. And here the radius 2 is equal to root of g square plus f square minus c, which is equal to 3 square plus 4 square, which is 25 minus 49. Sorry, this is not G and F. This is only like question number 50. The number of common tangents to this and this circle is equal to. So here you have the two circles, which is x square plus y square is equal to 4. That means here the center is origin and the radius is root of 4, which is 2. And the second one is x square plus y square minus 6x minus 8y minus 24 is equal to 0. So you have x minus, I'm making the perfect squares out of it, x minus 3, y minus 2 square. I'm adding a 9 and 16. That means I have to subtract 25 minus 24. So this is x minus 3 square, y minus 4 square is equal to 49. Here the center is given by 3, 4 and radius is equal to 7. I can't take the negative value, so that is 7. So let's say this is R1 and what we'll have for R1 and R2. First of all, let's find out C1, C2. Distance between the two centers. This is given by, this is C1 and this is C2. So the distance is given by 3 minus 0 square, 4 minus 0 square, which is equal to 5. This is C1, C2. Now let's find out the distance between like R1 minus R2 mod. So that is 7 minus 2, or sorry, this is 2 minus 7. So that means this is 5, which means that C1, C2 is equal to mod of R1 minus R2. That means circles touch each other internally. Therefore, how many common tangents they have? 1. Okay, so that makes option A to be the correct answer. Hope you understood this. Next is question number 51. The equation of the circle whose radius is root of 10 and touches this circle externally at this point is given by this equation. Then what is the value for modulus of A plus B plus C? Okay. So you're given the circle as x square plus y square to x 8y minus 23 is equal to 0. Now equation of the new circle, let's say this is equation 1. Equation of new circle touching equation 1 at the point 1, 2 is x square plus y square 2x 8y minus 23 plus lambda x minus 1 square plus y minus 2 square is equal to 0. Okay, so that's it. Let's solve it further. Like x square, I'm segregating the terms. This will be 1 plus lambda x squared plus 1 plus lambda y squared plus 2 minus 2 lambda into x plus 8 minus 4 lambda into y minus 23 plus 5 lambda is equal to 0. So that makes x square plus y square, because I want the coefficients of x square and y square to be 1 minus 2, 1. I'm taking this 2 common from here, and numerator will have 1 minus lambda and 1 plus lambda in the denominator. Plus I'm again taking the 4y lambda minus 2 upon lambda plus 1 plus 5 lambda minus 23 upon lambda plus 1 is equal to 0. Let's say this is equation 2. Right? Hope you understood till here. Now, you are given that radius equal to root 10. That means, see, you know the radius is given by root of g square plus f square minus c. So that means radius square, which is equal to 10 in this case, is equal to g square plus f square minus c. So 10 is equal to what is g? That is lambda 1 minus lambda. Yeah. 1 minus lambda upon 1 plus lambda square plus lambda minus 2 upon lambda plus 1. Say here I am having f is half the coefficient of y. So this is 2 into this. 2, when I'm doing the square of it, it will be 4 over here. Whole square minus this 5 lambda minus 23 upon lambda plus 1. So this is whole thing equal to 10. Now let's take the LCM. So here you have 10 is equal to 1 plus lambda whole square. And here you will have 1 minus lambda into 1 plus lambda whole square plus, no, wait. No, wait a minute. See, you are having already this, so there will be 1 minus lambda square. And here again, you will have lambda minus 2 square, 4 outside, minus lambda plus 1 into 5 lambda minus 23. Right, let's open it. Now this will be equal to 10 plus 10 lambda square plus 20 lambda. This is equal to 1 plus lambda square minus 2 lambda plus 4 lambda square plus 16 minus 16 lambda minus 5 lambda square and minus 23 plus 5. This is minus 18 minus plus, so plus 18 plus 23. So this is the whole thing. Now let's do all the cancellations and everything which is possible in this case. This is 4 lambda and this will cancel, and then you have here 10 lambda square, and here you have 20 lambda. Give me a minute. Plus 20 lambda. So minus 18, this will also cancel. Okay. So this is the only one. Here is plus 10, and then you have 17, and this is 40. So minus 40 is equal to 0. That means you have 10 lambda square plus 20 minus 30 is equal to 0, or lambda square plus 2 lambda minus 3 is equal to 0. That means I'm splitting the middle term. So you will have lambda square plus 3 lambda minus 3 is equal to 0. So two factors will be lambda is minus 3, lambda plus 3 and lambda minus 1 is equal to 0. That means you can have the two values for lambda as 1 and minus 3. Therefore, if I'm using lambda is equal to 1, equation 2 becomes x square plus y square plus 2y minus 9 is equal to 0. Therefore, if I'm comparing it with the general equation, which is given over here, this one, let's write down the equation. So you have the general equation as a, wait a minute. Okay. Ax square plus it was x square plus y square plus ax square plus by square plus c is equal to 0. So clearly you have a is equal to, sorry, ax plus by is equal to 0. So clearly you have here a is equal to 0, b is equal to 2, c is equal to -9. So that means a plus b plus c mod is equal to 0 plus 2 minus 9, which is equal to mod of -7. That is equal to 7. So this is a plus b plus c. Now at lambda is equal to -3. When I'm taking lambda is equal to -3, that equation 2 will be, equation 2 becomes x square plus y square minus 4x plus minus 10y plus 19 is equal to 0. Again, I'm comparing with the equation x squared plus y squared, ax by plus c is equal to 0. So here you have a as -4, b as -10, and c as 19. So that means you have a plus b plus c equal to -4 -10 plus 19, or this is equal to 5. So we have the two possible values of the a plus b and the c. That means you had the two values as 5 and 7, but 7 is not in the options. We have only 5 over here. That makes option A to be the correct answer. Hope you got that. Next is question number 52. If a circle S passing through the origin and having its center on the line x minus y is equal to 0, cuts the circle this orthogonally, then the diameter of S is. Okay, so here you have x square plus y square minus 4x minus 6y plus 10 is equal to 0. This is the equation of the circle. Let the circle pass through the origin. Circle pass through the origin centered on this line. X minus y is equal to 0. Is given by x square plus y square plus 2gx plus 2fy plus this is centered at origin, so this is equal to 0. The constant part is not there. So let's say this is equation 2 and let's say this is equation 1. Now because line 1 and circle 2, circle 1 and circle 2, wait, passing through the origin, having circle this, cuts the circle this orthogonally, because they both of them, they are, because 1 and 2 are cutting orthogonally. Therefore, that gives G is equal to F and C is equal to 0, which makes question number 52. If the circle S is passing through the origin and having its center on this line, it is cutting this circle orthogonally, which means 90 degree. Then what is the diameter of S? Fine. So this is the first circle, and let the equation of circle S, which is passing through the origin and having the center on this line. Okay, I'll discuss this later. First of all, equation of the circle S, which is passing through the origin, is given by x square plus y square plus 2gx 2fy is equal to 0. C is not there because it is passing through the origin, right? Let's say this is number 1 and let's say this is equation number 2. Now, both these equations cut each other orthogonally. If what is the condition for the orthogonal? If the two circles, they are cutting each other orthogonally, the condition should be satisfied is 2g dash plus f dash is equal to c plus C dash. So this is the first, this is the second, and this is the first equation. So from these, you have 2 is taken outside. Here I'm taking G, and here what is G? It is half the coefficient of X, so minus 2 plus F, half the coefficient of Y, which is minus 3, is equal to C. In this case is 0, and in this case C is equal to 10. So you have here minus 4G minus 6F is equal to 10, or 2G plus 3F plus 5 is equal to 0. Now, one more thing is there. G is equal to F in this circle. Why is that? See, the circle is having its center at this line x minus y is equal to 0. So, um, wait. The circle is having the center at the line x minus y is equal to 0. So that means x is equal to y for the center. If x is equal to y, so then that means this is G is equal to F. Since the circle S has center at origin. So what is the formula for the center? It is given by, sorry, not origin, at the line x is equal to y. So this is given by x or y. This is the line. So therefore, the center is given by minus half the coefficient of x minus half the coefficient of y. So that means G and F, they are equal. All right. Now let's get back to our equation number 3. So here you have equation number 3. 2G plus 3F plus 5 is equal to 0. I can say this is 2G plus 3G plus 5 is equal to 0. This gives me G is equal to minus 1. Now that was equal to F also. This gives you G is equal to F is equal to minus 1. What we had to find out was the radius of S. For that, let's find out the diameter we had to find out. Radius is given by G square plus F square minus C. C is missing in this case. So minus 1 square plus minus 1 square plus 0. This is equal to root 2, and diameter is 2 root 2. So this is the answer to the question, and you have option C as the correct answer. Hope you understood this. Next question number 53. The equation of the circle passing through the point of intersection of these two circles and having the radius root 13 is, so equation of the required circle. This is given by x square plus y square plus 6x 4y minus 12 plus lambda x square plus y square minus 4x minus 6y minus 12 is equal to 0. So I'm taking common. This will be x square 1 plus lambda y square 1 plus lambda. Then you have 6 minus 4 lambda x 4 minus 6 lambda y. And for the constant, you have minus 12. I'll take common 1 plus lambda. Okay, this is equal to 0. Yeah, so let's divide both the sides by 1 plus lambda. You will have x square plus y square plus 6 minus 4 lambda upon 1 plus lambda into x plus 4 minus 6 lambda upon 1 plus lambda y minus 12 lambda plus 1 whole divided by, okay, I'll leave it like this. This is equal to 0. All right. Now you're given that the radius of the circle is root 13. So what is the formula for the radius? That is given by G square minus F plus F square minus C whole under the root. This is equal to, what is G? G is half the coefficient of X. So this is given by, I'm dividing it already. So this will be 3 minus 2 lambda upon 1 plus lambda whole square. And F is half the coefficient of Y, which is 2 minus 3 lambda upon 1 plus lambda. And minus plus, this is this. Okay. So that's given to you as root of 13. So you will have it as, okay, I'm canceling the roots. So this will be 1 plus lambda. I'm opening the numerator. So this is 9 plus 4 lambda square minus 12 lambda plus 4 plus 9 lambda square minus 12 lambda plus 12 plus 12 lambda. This is equal to 13. So this and this is cancelled. What else is cancelled is, let's see. So here you have one thing, there was lambda square. Wait. I did a mistake. Here was lambda supposed to be lambda square. So this whole thing will change now. This will be equal to lambda plus 1 whole square. And this is 9 plus 4 lambda square minus 6 into 12 lambda, right? Plus 4 plus 9 lambda square minus 12 lambda plus 12 into lambda square plus 1 plus 2 lambda. This is equal to 13. Okay, so now let's combine the like terms. So here you have 13 and this. So you have lambda square over here. This is 13 and this is 12. So sorry, this is 13 and 12. So we have 25 lambda square. Then you have here wait. Then you have minus 24 lambda and this will be plus 24 lambda. Then you have 9 and plus 13 plus 12 is equal to 13, 1 plus lambda square. So this is equal to, yeah. So this is equal to 25 lambda square. These two will cancel. Plus 25 is equal to 13 plus 13 lambda square plus 26 lambda. Or here you have a 12 lambda square minus 26 lambda plus 12 is equal to 0. Or dividing both sides by 2, you have 6 lambda square minus 13 lambda plus 6 is equal to 0. So splitting the middle term, you will have the two factors as this is this and 9 lambda, 4 lambda plus 6. So 3 lambda is taken common, 2 lambda minus 3 minus 2 lambda minus 3 is equal to 0. So you have the two values of lambda as 2 by 3 or 3 by 2. So these are the two values for lambda. First of all, if I'm having lambda is equal to 3 by 2, you have the equation as x squared plus y squared minus 2y minus 12 is equal to 0. Putting the value of lambda is 3 by 2. And second, if you put the lambda value as 2 by 3, you will get the x squared plus y squared plus 2x minus 12 is equal to 0. So these are the two equations, right? Out of this, you have, this is the one, minus 2y minus 12 is equal to 0. Option C is the correct answer. Hope you understood this. Let's move to the next question, number 54. If AB is the local chord of this parabola and A 1 comma minus 4, then the equation of the normal to the parabola at the point B is, fine, you're having the parabola 16x. So what is like at the point 1 comma minus 4, you have this as 4t square 8t, right? So from here you have the value of t as like 8t is equal to minus 4. That will give you t is equal to minus 1 by 2 from here. So this is the parabola somewhat like this. Y square is equal to 16x. This parabola is going to be something like this. And if this is the point A, let's say 1 comma minus 4. So this is going to be, let's say this is the point B. And I have to find out B point coordinates. Okay, so this is the point B. So the coordinates of B will be given by 4 upon t square minus 8 upon t, which will give you the B's coordinates as 16 comma 16. right? So these are the coordinates for B. Now equation of the normal at the point B will be given by equation of normal at B, that is 16, 16 is given by the general equation is y is equal to minus t1x plus 2at1 plus a t cube, t1 cube. So here, if I'm seeing the point this B, this is given by, the coordinates are given by minus okay, so this is equal to 4t1 square and 8t. From here you have t's value as, see, 8t is equal to 16. From here you have the t value as t1, actually t1's value as 2. From here also you get the t1's value as 2 only. So this is it. T1 is 2 in this case, so minus 2 into x, and a 6 y square is equal to 4ax. This is equal to 16x, which simply means a is equal to 4. So this is equal to 2 into 4 into 2 plus this is 4 into 2 cube. So you have this one as y is equal to minus 2x plus 16 plus 32. So 2x plus y minus 48 is equal to 0. This is the equation, required equation, right? And 2x plus y minus 48, this is equation option B. 2x plus y minus 48 is equal to 0. This is the answer to the question. Let's move to the next question, number 55. If one of the vertices of an equilateral triangle inscribed in this parabola coincides with the vertex of the parabola, then the area in square units of that triangle is. You are given the parabola y square is equal to 12x. One of the vertices of an equilateral triangle inscribed in this parabola coincides with the parabola, then with the vertex of the parabola. So see, this parabola will, this whole figure will look something like this. This is the parabola y square is equal to 12x. And here you have the equilateral triangle. So let's say this is A, and let's say this is point A, and this is point B. So here you have, and here you have. Okay. So this AOB is an equilateral triangle. This is 0, 0. And if I'm saying the A's coordinates are given by, see, these are given by 3t square, then this is 60. See, A, 3t square and 60. And B is 3t square minus 60. I hope you got this. Like A, this is given by, A's coordinates will be given by 80 square and 280. Y square is equal to 4 into 3 into x. So A in this case is 3. So 3t square comma 60. These are the two coordinates for A and B. Now you are given that this is an equilateral triangle, which means OA is equal to OB is equal to OC. You have the coordinates of all of them. This is 3t square and minus 60. So let's see the sides. OA square is equal to OB is equal to, not, sorry, this is equal to AB. Okay. So what is OA? OA is given by 3t square minus 0 whole square plus 6t minus 0 square is equal to 12t square. This you will get as 9 plus 36. So 90 square whole square plus, sorry, 90 raised to power 4 plus 36t raised to power 2 is equal to 144 t raised to power 2, or 94 is equal to 108 t square. So from here you have t is equal to, solve it. So you will get the value of t as 2 root 3. I think you can solve this. Now you got the side of triangle as 20, which is equal to 24 root 3 centimeter. Therefore, area of triangle, you know, this is given by root 3 by 4 into side square for an equilateral triangle. So root 3 by 4 into 24 root 3 into 24 root 3. This on solving will give you 432 into root 3 square units. Right, so this is the answer to the question, and let's check with the options. You have option D as the correct answer. Hope you understood this. Let's move to the next question, number 56. If an ellipse with the axis as coordinate axis 2a and 2b as the length of the major and minor axis respectively passes through this and this points, then 3a square plus 5b square is equal to. Okay, so this is the general equation of the ellipse. X square upon a square, y square upon b square is equal to 1. Now at the point this will be 4 upon a square, 4 upon b square is equal to 1, or you have 1 minus 4 upon b square is equal to multiplied by this is equal to 1 upon a square. Now at the second point 3 comma 1, you have 9 upon a square, 1 upon b square is equal to 1, which gives you 1 minus 4 upon b square. Here I'm multiplying this. So plus 1 upon C. What I have done is I have just filled in the value of 1 upon A square as this, right? So this plus 1 upon B square is equal to 1. I'm using equation 1 here. Okay. So further, this is equal to 9 by 4 minus 9 upon b square plus 1 upon b square is equal to 1, or or you have 5 by 4 is equal to 8 upon b square, which gives you b square is equal to 32 by 5. And using same, you had a square is equal to 1 by 4 sorry, 1 by 4 4 upon b square. Solving this whole thing, you will get a square as 32 upon 3. All right. Okay, so if you are filling, just have the cross check. 1 by 4, 1 minus 4 upon 32 into 5. So you have 1 by 4, 3 by 8. So this gives you 1 by a square. So this gives you a square is equal to 32 upon 3, right? Now, you got the value for a square as 32 by 3. What we needed to find out was 3a square plus 5b square. So 3a square plus 5b square will be equal to 3 into 32 upon 3, 5 into 32 upon 5, which is equal to 64. So this is the answer to the question. Option C is the correct answer. Hope you got this. Let's move to the next question, number 57. So it says the value of C such that the line y is equal to 4x plus C touches this ellipse is. Okay, so you're given the ellipse as x square upon 4, y square upon 1 is equal to 1. And here you have C is equal to plus minus root of a square m square plus b square. So this gives me plus minus root of what is a square, that is equal to 4. M square is equal to 4 square. See, from here you have this is, if I'm comparing y is equal to mx plus c, you have m is equal to 4 in this case and b is 1. So this gives me plus minus root of 65 as the value of c. So simple as that. We have option C as the correct answer. Hope you understood. Next question, number 58. If the line this touches this hyperbola, then what are the point of contact of both of them? Okay, so given this line 2x plus root 6y is equal to 2. This touches this parabola x square minus 2y square is equal to 4. Let's say they their point of contact is h comma k. So, okay, so t is equal to 0 when hx minus 2ky is equal to 4. On comparing, you will get like h upon 2 is equal to minus 2k upon root of 6 is equal to 4 by 2, which is equal to 2. This gives me h is equal to 4 and k is equal to minus root of 6. So the point h comma k, this becomes 4 minus root 6, which is option B. Hope you got this. Next question number 59. If the circumcenter of the triangle formed by these 3 points is alpha, beta, gamma, then what is the modulus of alpha plus modulus of beta? So the 3 points are these, and here you have, I'm not writing the points. The AB vector will be given by, this will be 2i minus 3j, and 5 minus this will be plus 2k. 5 minus 3, this is plus 2k. Similarly, you will have AC as this is A and C. Okay. So you have 4 minus 1, which is equal to 3i cap, and 0 minus 2 minus 2j cap, minus 3, which is equal to 6k cap. All right. So if I'm taking the dot product of AB and AC, this will be equal to 6 plus 6 minus 12, that is equal to 0. If the dot product of the two vectors is equal to 0, that means they are perpendicular to each other, which means these vectors are perpendicular to each other. Right? A is common, so they are perpendicular at point A. Hence, circumcenter will be the midpoint of the hypotenuse. Circumcenter will be midpoint of hypotenuse, which is BC. And you had the coordinates of this is B and this is C, this is A. Let's find out the midpoint of it. So midpoint BC is equal to 4 plus 3 upon 2, 0 plus 1 upon 2, minus 3 minus 5 upon 2, which is equal to 7 by 2, 1 by 2 minus 4. Wait. B and C. Sorry, this is plus. Okay. Yeah, the 5 is of plus over here, and this is equal to 1. Okay, I'm rewriting the midpoint, which is given by 7 by 2, 1 by 2, and 1. So let's say this is like circumcenter, this is given by O. And what you need to find out was magnitude of alpha plus beta. So this is, you are given the question that this is equal to alpha, beta, gamma. So that means 7 by 2 plus 1 by 2, which is equal to 4. And 4 is not in the options, but you have gamma from the options. What is gamma? It was equal to 1. So this is equal to 4 gamma. That makes option C as the correct answer. Hope you got that. Next is question number 60. Theta is the acute angle between the two lines whose direction cosines are connected by these relations. Then what is the value of cos theta? So here you have L plus M plus N is equal to 0. That makes L minus M plus N. L is equal to M minus of M plus N. Also, we are given 2LM plus 2NL minus MN is equal to 0. I'm taking minus 2 common, M plus N whole square minus MN is equal to 0. So yeah, I hope like you understood what I did over here. I'll rewrite this line again to make it more clear. I have taken 2L common from here, and this will be minus I have taken outside. This will be M plus N. And yeah, here will be plus Mn is equal to 0. And L was equal to this. So this will be M plus twice is out, 2 is outside, m plus n whole square. Question number 60, if theta is the acute angle between the two lines whose direction cosines are connected by this and this, then what is the value for cos theta? So first of all, you have L plus M plus N is equal to 0. That makes L is equal to minus M plus N. Also, you have 2LM plus 2NL minus MN is equal to 0. I'm taking 2L common. M plus N minus MN is equal to 0. So 2L, I'm replacing L by m plus n. So this will be minus 2 m plus n whole square minus m into n is equal to 0. Let's open it up. So you have here 2m square minus, I'm keeping outside, 2m square, 2n square plus 4, yeah, 4mn. Minus mn is equal to 0. This makes minus 2m square minus 2n square minus 5mn is equal to 0. Or you have 2m square plus 2n square plus 5mn is equal to 0. So from here you have the two values. You will solve out 2m square plus 5mn plus 2n square is equal to 0. 2n square plus 4mn plus mn plus 2n square is equal to 0. 2m plus 2n, and here I'm taking n common. M plus 2n is equal to 0. Two factors will be 2m plus n. M plus 2n is equal to 0. From these two, you have the m by n values. Two values will come, that is minus 2 and minus 1 by 2. Now add the two values. At m by n is equal to minus 2, you will have m is equal to minus 2n. Or in that case, you will have L is equal to n and n is equal to, so here the direction, wait, yeah, okay, so you have the direction ratios as 1 and minus 2 and 1, right? At the second one, when m by n is equal to minus 1 by 2, you will have, you had this thing now, L is equal to minus m plus n. So here you have m is equal to, or you have n is equal to minus 2m. That gives you L is equal to m, and of course m is equal to n. So this is 1, 1 and minus 2. Cos theta, that is the theta between, that is the angle between both of them. This is given by, it is 1 into 1, 1, minus 2 into 1, minus 2, minus 2 into 1, minus 2, whole divided by root of 1 square plus 2, minus 2 square plus 1 square multiplied by root of 1 square plus 1 square plus 4. So that is equal to minus 3 upon root of 6 into root of 6, which is equal to 6 ultimately. That gives you 1 by 2 as the answer. That means you have option A. Here is the correct answer. Hope you understood this. Next, question number 61. If the foot of the perpendicular drawn from this point to the plane pi is this, and the equation of the plane pi is given by this, then what is the value for a square plus b square plus c square? So here we have ax plus by plus cz is 2. Foot of perpendicular is given by x minus 1 upon a plus y minus 0 z. Sorry, here is y minus 0 upon b, z plus minus 2 upon c. That gives me, this is equal to minus a, yeah, minus a plus 0 minus 2c minus 2 whole divided by a square plus b square plus c square. So this, you are given the foot of the perpendicular is 201, given foot of perpendicular is 2, 0, and minus 1. So therefore, you have this becomes 2 upon A 0 and this. This is equal to minus A minus 2C minus this whole divided by, not root, sorry, A square plus B square plus C square. So that's 1 by A is equal to 0 upon B, 1 upon C is equal to 2C minus A plus 2 whole divided by A square plus B square plus C square. That gives you B is equal to 0 and A is equal to C. Also 1 by A is equal to here 2A minus A plus 2 upon A square plus B square plus C square. That gives me 2A square upon A is equal to A plus 2, right? Because B was equal to 0 and A was equal to C. So here you have 2A is equal to A plus 2 or A is equal to 2. That means A is equal to C. That means C is equal to 2 and B is equal to 0. So you have to find out A square plus B square plus C square, which is 4 plus 0 plus 4, that is 8. So this is the answer to the question. Option B is the correct answer. Hope you got that. Next is question number 62. So limits problem. Limit x approaching 0. You have to find out the value for this expression. Okay, I'm using the rationalization first of all. So this becomes 2 tangent x plus cos x minus 1 plus x. This whole thing is multiplied by root 4 sine square x plus 2 tangent x plus 1 plus root 3 tangent square x plus sine x plus 1 whole thing divided by 1 root of 4 sine square x plus 2 tangent x plus 1 minus root 3 tangent square x plus sine x plus 1, like whole thing, right? And here I'll be multiplying with this one. So root 4 sine square x plus 2 tangent x plus 1 plus root 3 tangent square x sine x plus 1. All right. This is limit x approaching 0. So now I can write it like I'm taking this as I'm taking x outside, limit x approaching 0. This will be 2 tangent x upon x minus, I can write like this, 1 minus cos x upon x square into x. Why I'm doing so, it will just come to know. And plus 1. Right. Okay, so this one, and here you have the limits. I'm putting the limits over here. So this will be root of 0 plus 0 plus 1 plus root of 3 into 0 plus 0 plus 1 whole divided by, this whole thing is divided by, I'm opening up like them. This is a plus b into a minus b. This will be a square minus b square. Okay, so this will be equal to limit x approaching 0, x into this will be 2 tangent x upon x minus, this can be written as 2 sine square x by 2 upon x square into x plus 1 whole root 1 plus root 1, that is equal to 2. Okay, and this whole thing now is divided by, sorry, the divisions from here. So this whole thing is now divided by, I'm putting in the x is equal to 0. So you have here 4 into 0 plus 2 into x approaching 0. This is tangent of x. Question number 62, limit x approaching 0, this whole expression is equal to. So I'm just doing the rationalization at this step only. I'm multiplying it by root sine 4 sine square x plus 2 tangent x plus 1 plus root 3 tangent square x sine x plus 1. Whole thing divided by the same thing. 4 sine square x 2 tangent x plus 1 plus you have 3 tangent square x plus sine x plus 1. Okay, now let's solve it further. So you have limit x approaching 0. I'm writing this thing as in some modified way, like I'm taking x common. So this is 2 tangent x upon x minus 1 minus cos x upon x square into x plus 1. And this thing I'm just putting the limit. So this will be root of 0 plus 0 plus 1 plus root of 0 plus 0 plus 1. Whole thing divided by, see, I'm directly writing this is a square plus b square. So 4 sine square x 2 tangent x plus 1 minus 3 tangent square x minus sine x minus 1. So that makes limit x approaching 0. I'm writing like 2 tangent x upon x minus this can be written as 2 sine square x by 2 upon x square into x plus 1 into 2. This whole thing is being divided. I'm taking sine x common and this x which was written over here, I'm getting this down. Okay, see, I'm doing two things. I'm getting the sine x common from this and I'm getting this x in the denominator. So here you will have 4 sine x, 2 secant x, they will cancel. Then you have a minus 3 secant x, tangent x, and minus 1. Okay, now let's fill the remaining limits. Here you have this is equal to 2 minus this is equal to 0, right? 1 into 0, so this is 0 and plus 1 into 2 whole divided by this is 1 into 4 like 0 plus 2 minus 0 minus 1. So this is equal to 6. This is the answer to the question. Option C is the correct answer. Hope you understood this. Let's move to the next question. Question number 63, for function f is defined by f(x) is equal to this. X is not equal to pi by 4. Then what is the limit x approaching pi by 4 f of x? So you have here limit x approaching pi by 4 f of x. That means cot cube x minus tangent x whole divided by cos of this. So for the limits, let's put x is equal to pi by 4 plus h. So you have when h approaching 0, limit h approaching 0, this becomes 1 minus tan raised to power 4x whole divided by tangent, sorry. Question number 63, for function f is defined by fx is equal to this when x is not equal to pi by 4, then the limit of x approaching pi by 4 fx is equal to. So according to the question, you have to find out limit x approaching pi by 4 fx, which is given by cot x minus tangent x whole thing divided by cos of x plus pi by 4. Let's put x is equal to pi by 4 plus h for the limit. So this limit will be now limit h approaching 0. This can be written as see, this can be written as cot cube can be written as 1 upon tangent cube pi by 4 plus h minus tangent pi by 4 plus h whole divided by cos of pi by 4 plus 4 plus h plus pi by 4. Okay. So this is limit h approaching 0. This will be 1 upon tangent cube pi by 4 plus h into cos pi by 2 plus h, which can be written as minus sine of h. And this is 1 minus tangent cube, tangent raised to power 4 pi by 4 plus h. Hope this is clear till here. So now this is equal to limit h approaching the infinity. This is a square minus b square. This can be written as 1 plus tangent square pi by 4 plus h into 1 minus tangent square pi by 4 plus h. Whole thing divided by um, tangent cube pi by 4 plus h, and separating them, this is minus sine h. Limit h approaching 0. So this is this is 1 plus, I'm putting the limits, tangent when h is approaching 0, this is 1 upon tangent cube. So this is equal to 1. Okay, now limit h approaching 0. Again, this is a square plus b square, which can be written as 1 plus tangent pi by 4 plus h 1 minus tangent pi by 4 plus h whole divided by minus sine of h. So this becomes 2 into limit h approaching 0, 1 plus tangent pi by 4 plus h into 1 minus tangent pi by 4 plus h. I'm dividing this with 1 plus tangent pi by 4 plus h multiplied by this. Okay, so when I'm dividing this, so this will be square. Hope this is clear. So this is 2 into limit tangent. See, this is better to write it like this: limit h approaching 0, 1 minus tangent pi by 4 plus h upon 1 plus tangent pi by 4 plus h, and then I'm separating 1 plus tangent pi by 4 plus h whole square upon minus sine of h. So this becomes 2 into limit h approaching 0. See, this is 1 minus tan something upon 1 minus tan a upon 1 plus tan a. The formula for this is tangent pi minus pi by 4. See, 1 can be written as tangent pi by 4. So this is tangent pi by 4 minus pi by 4 minus h upon, here's the limit h approaching 0 upon minus sine of h. And this is multiplied by, this will be 1 plus 1 square. 1 plus 1 square. This makes it 2 square. So I'm taking it outside. 2 into 4, 8. Limit h approaching 0, this will cancel. You have tangent of minus h upon minus sine of h, which will be equal to, like, minus minus tangent minus h, it will be cancelled. You have limit 8 into limit h approaching 0 minus 8 sine h upon cos h into 1 upon sine h. Okay, sorry, no, 8 is not here. And this minus will cancel also. So you have this as 8 into limit h approaching 0 secant of h, right? Which is equal to 8. So this is the answer to the question. Option B is the correct answer. Hope you understood this. Next is question number 64. If fx is equal to root of x and x is greater than or equal to 0 and g of x is equal to this, then what is f of g dash x? So in the question you have fx is equal to root x and x is greater than or equal to 0. Also you have gx is equal to 1 plus x square. So what is f of g of x? Root of x square plus 1, and its first derivative will be given by this. So 2 and 2 will cancel, and what do you have to find out for 1? So f of g dash for 1, this is equal to 1 upon 1 square plus 1 into 1, that is equal to 1 root 2, 1 by root 2. Option D is the correct answer. Hope you understood this. Next is question number 65. So mix and match. You have listing. You have to match the values of dy by dx at x is equal to pi by 3 for the following system of curves in the parametric form of list 1 with the list 2. Okay, so first is you have x is equal to a theta minus sine theta. Y is equal to a1 minus cos theta. You have to find out dy by dx. Simply you have to first of all find out dx by d theta. So dx by d theta, this is equal to a1 minus cos theta. Also dy by d theta will be equal to a0 minus this cos will be minus sine theta. So this will be a sine theta itself. What will be dy by dx? This will be the division of dy by d theta with dx by d theta, which will be a sine theta upon a1 minus cos theta. That will give you sine theta upon 1 minus cos theta. Sine theta can be written as 2 sine theta by 2 cos theta by 2 divided by 1 minus cos theta can be written as 2 sine square theta by 2. So ultimately the answer will be cotangent theta by 2. Okay. So cotangent theta by 2. Okay, we have to find out for pi by 3. So dy by dx for theta is equal to pi by 3. This is cotangent pi by 6 it will be because it's divided by 2. So this is cotangent pi by 6. This is equal to root 3, which matches it with option C. Hope you understood this. Now let's go for the second one. Here you have in the question x is equal to 3 cos theta minus 2 cos cube theta. X is equal to 3 cos theta minus 2 cos cube theta, and y is equal to 3 sine theta minus 2 this. So here you have dx upon d theta. This is equal to minus 3 sine theta plus 6 sine theta cos square theta. And dy by d theta is equal to 3 cos theta minus 6 sine square theta cos theta. So ultimately you have dy by dx is equal to dy by d theta upon dx by d theta, which will give you 3 cos theta minus 6 sine square theta cos theta whole divided by this. Yes. Okay. So further, this will be, I'm taking the 3 common and cancelling it. First of all, I'll take 3 cos theta only common, 1 minus 2 sine square theta whole divided by 3 sine theta on this. So this will be equal to 3 and 3 will cancel. See, cos square theta minus 1 minus 2 sine square theta whole divided by see there is something here was 2, okay, and so this is 2 cos square theta minus 1 is equal to, this is the formula for cos 2 theta cos 2 theta. So you have this, and dy by dx at theta is equal to pi by 3 is cotangent of pi by 3, which is 1 by root 3. So this makes option D to be the correct answer. Hope you got that. Let's move to the third part of the question. So here we have the third portion. In this one, you had x as 3 cos theta, cos cube theta, y 3 sine theta minus sine cube theta. So here you have dy by d theta as equal to 3 cos theta. Yeah, minus 3 sine square theta cos square theta, and dx upon d theta is equal to minus 3 sine theta plus 3 cos square theta sine square theta. So dy by dx will be equal to dy by d theta upon dx by d theta, that is equal to 3 cos theta. I'm taking common directly, okay? Into 1 minus sine square theta whole divided by, here I'm taking minus 3 sine theta or 3 sine theta itself. Okay, minus 3. So this will be 1 minus cos square theta, right? 3 and 3 will cancel. And this will be equal to cotangent theta minus cotangent theta, and 1 minus sine square theta. This is cos square theta, and this is sine square theta. Right. Ultimately, you will have here that will be minus cotangent cube theta. Okay. Now dy by dx at pi by 3 is equal to minus cotangent cube pi by 3, which is equal to minus of 1 by root 3 whole cube. So this is 1 upon 3 root 3. This is the answer to the question, and here you have option B as the answer. This is the third part, right? Now let's move to the fourth part of the question. In the fourth part, you had x is equal to a log sine theta, y is equal to a tangent of theta. X is equal to just a minute. X was equal to a log sine theta, I think it was this, and y was equal to a tangent theta, a log sine theta, a tangent theta, a tangent theta. So dy by d theta will be equal to a secant square theta, and dx by d theta will be equal to a upon sine theta into log into this derivative of sine theta, which is equal to cos theta. So this will be a cotangent of theta. What will be dy by dx? This is equal to division of both of them. So a secant square theta upon a cotangent theta, which will give you sine theta upon cos cube theta. So dy by dx at x is equal to pi by 3 is equal to sine pi by 3 cos cube pi by 3. Sine pi by 3 is given by root 3 by 2, and the cos cube pi by 3 is equal to 1 by 2 cube, which is 1 by 8. So the answer to the question is 4 root 3. This makes, yeah, here it is, option 4. So now let's check with the options, which one you have as the answer. So here you have 1 goes with C, 2 goes with D, and 3 goes with the B. So here 4 goes with A. Here you have option A as the correct answer. So you can check from all these options. All right. Hope you understood this. Next is question number 66. Y is equal to x sine x, and dy by dx minus y upon x divided by this at x is equal to alpha is 1. Then alpha is equal to. Here you have x is equal to a theta minus sine theta, and Sorry, the question was y is equal to x sine x. So here you have y is equal to sine x into x. So what will be dy by dx? This will be equal to first function to derivative of second plus second function into derivative of first. Now, what is this one? To find was dy by dx minus y upon x whole divided by x into dy by dx minus y. This is x cos x. Yeah, this is for solving this, I would like to simplify it a bit further. So this will be dy by dx minus y upon x whole divided by dy by dx. I'm taking the x common, y upon x. So ultimately these two will cancel. So it has been very much simplified. 1 upon x is only 1 at x is equal to alpha. So this makes 1 upon alpha and this is 1. So that's 1 which makes alpha is equal to 1. Simple as that. I didn't need to find out this thing. Anyways, we got the answer. That is option C. Right? Hope you got that. Next is question number 67. A ladder of length 13 meters had one end resting along a vertical line and the other on the ground. If the lower end moves away from the wall at a speed of 2 meters per minute, then the speed in meters per minute at which the upper end falls when the bottom is 5 meters away from the wall is. Fine. So here you have x square plus y square, the length of the ladder. See, if I'm taking this as the x and y. So if I'm taking this length as x and this length as y, the length of the ladder is 13 meters. So this, so x square plus y square is equal to 13 square. You know, this is by the Pythagoras theorem. So let's differentiate it. You have to x into 1, dx upon dx into 1 plus 2y dy by dx is equal to 0. Right? So 66, if y is equal to x sin x and this expression at x is equal to alpha is equal to 1, then what is the value for alpha? You're given y is equal to x sin x, so that means dy by dx first function into derivative of second plus second function into derivative of first. So this will be x cos x plus sin x. Now this thing, let's solve. You're given dy by dx minus y upon x whole divided by x into dy by dx minus y. I can rewrite this as dy by dx minus y upon x whole thing divided by. See, now we'll do what? I'm taking this x like this. I can write it like x into dy by dx. Can I write it like this? Minus y upon x, right? Yes. Now this is equal to, say, these two things will cancel and you have this as x 1 upon x. Now this at x is equal to alpha. At x is equal to alpha, this is equal to 1 by alpha and this is equal to 1. So that means you have alpha is equal to 1. We have option C as the correct answer. Hope you understood this. Next is question number 67. A ladder of length 13 meters has one end resting against the vertical wall and another on the ground. If the lower end moves away from the wall at the speed of 2 meters per minute, then the speed in meters per minute at which the upper end falls when bottom is 5 meters away from the wall is. All right, let's make the diagram first. So here is the wall, here is the ladder, and this is the diagram. Now the ladder is 13 meters. It's resting against the vertical wall and it is moving away at the rate of 2 meters per minute. 2 meters per minute. Then the speed in meters per minute at which the upper end falls when the bottom is 5 meters away from the wall. Okay, so let's say this is x and this is y. When bottom is 5 meters, you have to find out that what will be this, what will be speed at which the upper end is falling down. All right. So here you can say, according to the Pythagoras theorem, x squared plus y squared is equal to 13 square. So let's find a derivative of it with respect to the time. So you have here 2x dx upon dt plus 2y dy upon dt is equal to 0. That gives you x dx upon dt plus y dy upon dt is equal to 0. You know, dx by dt you are given this is equal to 2 and this x is 5. See, it has asked for this. And y, I don't know what is y. First of all, let's find out y. See, when you have x is equal to 5, so this will be 5 square plus y square is equal to 13 square. So y square is equal to 169 minus 25, which is 144. So y is equal to 12 meters. All right. So here you have y as 12 and you have to find out dy by dt. That makes it 5 into 2 plus 12 into dy by dt is equal to 0. So that makes dy by dt is equal to minus 10 upon 12 or minus 5 upon 6. So since it is coming down, so that negative sign shows that it is coming down. Therefore, the speed by which the upper end is falling is speed at which upper end is falling is 5 by 6. All right. So this is the answer to the question. And we have option C as the correct answer. Hope you got that. Next is question number 68. An angle between the curves x square minus y square and this curve, you have to find out the angle between the curves. Okay, that's pretty easy now. So you have these two curves on solving. Let's write here. X square minus y square is equal to 4. X square plus y square is equal to 4 root 2. So you have 2x square is equal to 4, I'm taking common, root 2 plus 1, or x square is equal to 2 root 2 plus 1. So similarly on solving, you will find out that y comes out to be 2 root 2 minus 1. So now it's the time for finding out the slope of both the curves at the given point. So the first curve is given to you as x square minus y square is equal to 4. Let's differentiate it with respect to x. So you have 2x minus 2y dy by dx is equal to 0, which gives you x is equal to y dy upon dx, or you have dy by dx is equal to x by y. So let's say this is equal to m1, the first slope. Second curve is x square plus y square is equal to 4 root 2. Again, the same thing, 2x into dx upon dx, that's 1, plus 2y into dy by dx is equal to 0. Same thing, you have x minus x is equal to y dy by dx, or you have dy by dx is equal to minus x upon y. Let's say this is equal to m2. We got both the slopes of the curve, m1 and m2. Now you have to find out the angle between them. So the angle between them, that is the tangent theta, is given by m1 minus m2 upon 1 plus m1 into m2. So here you have this was equal to x upon y minus minus plus x upon y upon 1 minus x upon y into minus x upon y whole under the mod. So that's equal to root mod of 2x upon y whole divided by 1 minus x square upon y square, which is equal to 2x into y square upon y whole divided by y square minus x square. So this becomes 2xy upon y square minus x square. So now let's fill in the points. We had already x square was equal to 2 root 2 plus 1, and y square was 2 root 2 minus 1. So let's fill in this one. You have here, this is 2 into xy. What is xy? That is see, I'm doing x square and y square. Let's solve first of all over here in this side. X square and y square, the multiplication is, this is 4, and a plus b into a minus b, which would be a square minus b square, correct, which is equal to 4 only. So that is equal to 4 into 2 whole divided by y square is 2 root 2 minus 1 minus 2 root 2 plus 1. Correct? So that gives you, yes. Sorry, there is one thing. There is x square, y square, and this is xy, right? So this will be root of 4. This gives you mod of 4 upon 2 I'm taking common, minus 2 root 1 minus root 2 minus 1. So these 2 will cancel and you have 4 upon 2 minus 2 whole under the mod, which will be equal to 1. Okay. So you have 1. That is a tangent of theta. Correct. Tangent theta came out to be 1. What will be value of theta? That will be equal to pi by 4. So here you have option B as the correct answer. Hope you understood this. Next is question number 69. The maximum volume in cubic units of the cylinder which can be inscribed in a sphere of radius 12 units is. Okay, so here is a sphere of radius 12 units. You have to find out the maximum volume of the cylinder. Let's fit in a cylinder, inscribed a cylinder. Here is the sphere, and here we have inscribed a cylinder. This is the one, and this is the one. Okay. Okay. So the radius of the sphere is 12. So this is the, if this is the height of this from the center. This is the height of the cylinder, right? And this is like 12, right? And you know this is half of the height of the cylinder, correct? If this is the midpoint of the sphere, so this is half the height of the cylinder and this is equal to 12. Now, according to the Pythagoras theorem, if I'm considering this particular triangle, this one, so here you have h by 2 whole square plus r square is equal to 12 square, where this is r, that is radius of the cylinder. So here you can, r is radius of the cylinder, correct. So then you have r is equal to root of, this is equal to 144 minus h square upon 4. This is the r. Now volume of the cylinder will be, you know, volume of cylinder is given by pi r square h, right? And let's fill in the value for r square actually. So you have pi and r square was 144 minus h square upon 4 multiplied by h, which, okay, that's the volume. Now you have to find out the maximum volume. For that, you have to find out the first derivative of it with respect to h. So that is equal to pi 144 minus, this will be equal to 2h upon 4 into h. Right? Now for the maximum or minimum, you know this is equal to 0. That makes it 144 h. Yeah, 144 h. Wait. This is, I just need to change something. Wait. I'll open this up first, right? dy by dh is equal to the derivative of with respect to x. This pi, I'm just keeping it outside, and this will be 144h minus h cube upon 4. Okay, now let's find out the derivative, because that would have been first function derivative of second plus second function derivative of first. So I missed this h part. Now this is equal to 144 minus 3h square upon 4. For the minimum or maximum, you know that is equal to 0. So that gives you 144 minus 3h square upon 4 is equal to 0, or 3h square upon 4 is equal to 144, or 3h square is equal to 144 into 4. And let's cancel this, and you have here 48. So h square is equal to root of 48 into 4, which is equal to 8 root 3. Right? Yes, 8 root 3. Correct. So this is the value for h. So that means for the h is equal to 8 root 3, you have either the minimum or the maximum volume. Okay, let's see that. So dv, let's find out the derivative, second derivative. You had dv upon dh. It came out to be pi 144 minus 3h square upon 4. Let's find out dv upon dh square. So this is pi. This will be 0 and you have minus 6h upon 4. This is a negative value, less than 0. So that means volume will be maximum at h is equal to this, right? What we need to find out, the rest thing is maximum volume, which can be, okay, we have to find out the maximum volume. For that, let's find out the radius. Also, we got the height. Radius was equal to root of 144 minus, it was 144 minus h square upon 4. So h square upon 4 gives you 8 into 3 upon 4, which is equal to 48. So this is equal to, this will be equal to 4 root 6. Now the volume is given by pi r square h, or here you have pi's value is 22 by 7. I'll leave pi as such because see, options contain pi, so I will not open up this pi. I'll keep pi as such. R square was equal to this root of this is 16 into 6 and minus h, which is 8 root 3. So this makes it, yes, this makes it, on solving you will get 768 root 3 pi. This is the answer to the question. And now let's check with the options. Sorry, here is not minus, here is the multiplication. Okay, so here is 768 root 3h. This is option B. So this is the answer to the question. Next is question number 70. So you have to find out this integral problem. Solve this integral problem. Let's write it down. Tangent x, I'm keeping as such, and I'm keeping the secant square x as also as such. I'm breaking up this as 1 upon cos 6x dx. So that is equal to integral of tangent x divided by secant square x into cos raised to power 6x plus 1, and I'm multiplying this like this. Okay. Yes, so wait. Yeah, so this will be equal to question number 70. You have to find out the integral of this function. Let's start solving from here. So I'm going to break down the secant raised to power x as 1 upon cos x. After doing that, it will be something like this. Tangent x divided by secant square x. This will be cos raised to power 6x plus 1 upon cos raised to power 6x whole raised to power 2 by 3 dx. Now, this will be c cos raised, okay, integral of tangent x secant square x upon cos raised to power 6 into 2 by 3 x. So this will cancel with this one, and in the numerator you will be left with this. Okay. So then you have tangent x upon secant raised to power 6x cos raised to power 6x plus 1 dx. I'm going to open a tangent x as a sine x upon cos x, and secant x will be written as this. So you will have this. So numerator will be sine x cos raised to power 5x upon 1 plus cos 6x. This was whole raised to power 2 by 3 dx. Now, let's put 1 plus cos 6x is equal to t. Let's differentiate it. You have 6 cos raised to power 5x minus sine x dx is equal to dt. So now this thing in this, okay, let's solve it properly. You will have sine x cos raised to power 5x dx is equal to minus 1 by 6 dt. Now that integral will be, now that integral, let's say that was equal to I. So now this integral will be equal to, I'm taking the minus 1 by 6 outside, and this will be equal to dt upon t raised to power 2 by 3, which is equal to minus 1 by 2 t raised to power minus 2 by 3 integral dt. Sorry, 6 here was, and this is equal to minus 1 by 6 t raised to power minus 2 by 3 plus 1, that makes it 1 by 3 divided by 1 by 3 plus the constant c. So this is becomes minus 1 by 2 t raised to power 1 by 2 plus t raised to power 1 by 3, sorry, plus c. Okay, now let's fill in the value for t. You had the t as 1 plus cos raised to power 6 x raised to power 1 by 3 plus c. So this is the answer to the questions. Let's go back to the options and check. You have option C as the answer. Hope you understood this. Next is question number 71. So again, an integral problem before us. We have integral of 1 upon this whole expression dx is equal to. Let's all start solving from here itself. You can write it as integral of 1 upon, I'll break it up. I'll have 1x plus 1 raised to power 2. Can I write it like this? X raised to power x minus 1 upon x plus 1 raised to power 5 by 7, right? Dx. I hope I can write it like this. So now this becomes on, let's put down one thing, x minus 1 upon x plus 1 is equal to t. So let's find out the derivative now. Differentiate it. So this will be denominator square, denominator into this derivative of the numerator minus numerator into derivative of the denominator. Dx is equal to dt. That makes this x and x will cancel, and this will be 2 upon x plus 1 whole square dx is equal to dt. Correct? Hope that's clear. Now our integral, let's go back to that. So now our integral, this thing, let's say this is equal to I, this becomes, this will go like 1 by 2 integral of dt upon t raised to power 5 by 7, which is equal to 1 by 2 t raised to power 5 by 7 minus 5 by 7 plus 1, that will be 2 by 7 divided by 2 by 7 plus c. That makes it 7 upon 2, and let's fill in the value for t as well. That was equal to x minus 1 upon x plus 1 raised to power 2 by 7 plus c. So let's check with the options. Here you have option C as the correct answer. Hope you understood this. Next is question number 72. Again, an integral problem. So you just have to find out this. I'll do one thing. I'll put the cot x is equal to cos x upon sin x. Let's go for that. So this integral now becomes 1 plus root 3 cos x upon sin x whole divided by 1 minus root 3 cos x upon sin x dx. Now this becomes sin x, numerator, denominator will cancel like this. And here you will be left with sin x plus root 3 cos x whole divided by sin x minus root 3 cos x dx. Now I'll do one thing. I'm going to divide the numerator and multiply numerator and the denominator with 2. So this will be this thing whole divided by 2 sin x minus root 3 cos x dx. Now, why I'm doing this thing, you'll just come to know about it. Okay. So, okay, fine. Next thing, this is integral of, I'm going to, this was 2 sin x, right? And can I write that as 3 sin x minus sin x plus root 3 cos x plus root 3 cos x. This whole thing divided by 2 into sin x minus root 3 cos x dx. Okay, next thing what I'll do is I'm taking root 3 common from these two. So, yes, I'll have a root 3 sin x plus cos x plus, this will be, I'm taking the minus outside. So sin x minus root 3 cos x. Okay. This whole thing is divided by 2 sine x minus root 3 cos x dx. So this thing is equal to integral of now root 3 by 2 sine x, root 3 sine x plus cos x, whole thing divided by sine x minus root 3 cos x dx, and minus 1 by 2 integral of, like these two things will cancel, I will have 1 dx. Right? Hope this is clear till here. So now why I have done all of these things, you'll just come to know. See, this is, if I'm looking at this, this is the, I mean, derivative. Numerator is a derivative of the denominator. So this will be root 3 by 2 natural log of sine x minus root 3 cos x dx. Sorry, not the dx, minus half into this plus the constant c. So this is our answer, minus x by 2 plus root 3 by 2 natural log sine of x minus root 3 cos x. This can be written as sine x minus pi by 3 plus c. Question number 72. Integral of this whole expression is equal to what? So let's write it down over here. I'm breaking up that cos x as cos x upon sine x. This will be sine x plus root 3 cos x whole divided by sine x divided by sine x minus root 3 cos x divided by sine x dx. So these two things will cancel and you will have this as sine x plus root 3 cos x divided by sine x minus root 3 cos x dx is equal to. See, now I'll be doing some modifications, and for y, like you'll just come to know. One thing I'll be doing, I'll be multiplying the numerator and the denominator by 2. After that, this will be integral of, denominator will contain 2 sine x minus root 3 cos x, and the numerator will have 2 sine x, which can be written as 3 sine x minus sine x, and plus root 3 cos x plus root 3 cos x. Why I'm doing all this, we will shortly come to know. Now I'm taking the root 3 common from here, and inside you will have root 3 sine x plus cos x. Okay, and then ultimately here will be minus sine x minus root 3 cos x, whole thing divided by 2 into sine x minus root 3 cos x dx. Correct? Hope you understood this. Now, ultimately, this is equal to, I'm breaking this up, this will be root 3 by 2 root 3 sine x plus cos x, whole thing divided by sine x minus root 3 cos x minus 1 by 2. So these two things will cancel. I'm just writing here 1. Okay, I'm writing it properly. This will be equal to root 3 by 2 integral of cos x plus root 3 sine x divided by sine x minus this thing dx, and this will be minus x by 2 plus the constant c. Now you notice one thing. Here this is the numerator and the denominator, like this is the function, and then this is a derivative of that function. Right now, again, I'll be doing some modifications. You will. Why I have done all this is because I want to make the denominator and the numerator as a derivative of the denominator. That is why I have done all these things. Okay. Now, one more modification to match our answer with the given options. So I'm dividing numerator and the denominator by 1 by 2. Now, this will be equal to root 3 by 2. I'm taking this as a like outside. So this is a natural log of, this will be the natural log of 1 by 2 sine x minus root 3 cos x minus x by 2 plus the constant c. So 1 by root 3 by 2, this is natural log of sine x into 1 by 2 minus root 3 by 2 into cos x minus x plus c. Now this is equal to root 3 by 2 log of sine x minus pi by 3 minus x by 2 plus c. Now, why is this? See, 1 by 2, this can be written as, this was sine x into 1 by 2 minus root 3 by 2 into cos x. And this can be written as sine x cos pi by 3 minus sine cos x minus cos x into sine pi by 3. So ultimately, this is equal to sine x minus pi by 3, right? Now let's match this with the given options. Here you have option A as the correct answer. Hope you understood this. Next is question number 73. Integral of 1 upon cosecant x plus cos x dx is equal to this minus this plus c. Then at x is equal to pi by 3, what is the value for mod of the function fx? Okay. So first of all, let's pick up the left hand side. You have given 1 upon cosecant x can be written as 1 upon sine x. So this will be 1 plus sine x cos x, and sine x will be multiplied here dx. So this becomes, I'm multiplying the numerator and the denominator by 2 now. So this will be 2 plus this sine x cos x dx, which is equal to integral of 2 sine x. I will break up this sine x. I can write it like sine x plus sine x whole thing divided by 2 plus, now 2 sine x cos x, this is equal to sine 2x. I'm adding cos x and subtracting cos x from here dx. Now I'm going to break it down, split it up actually. This is equal to sine x plus cos x upon 2 plus sine 2x dx plus sine x minus cos x upon 2 plus sine 2x dx. If I compare it with the right hand side, see, this thing matches, and this thing is equal to, this is equal to this thing. Okay, 1 by 2 root 3 log fx. 1 by 2 root 3 log of x. Okay, so now this is it. Now I'll be solving this part. Because this has already matched. I need the fx, so I need to get my fx from here. Let's get to this much portion. Integral of sine x plus cos x upon 2 plus sine 2x dx. This can be written as integral sine x cos x upon, now I'm splitting 2 plus sine 2x. How I'm going to do that? Look at this one carefully. 3 minus sine x minus cos x whole square, because sine square x plus cos square x, this will be 1, and 3 minus 1, this will give me 2, minus 2 sine x cos x, that will be sine 2x, minus minus will be plus. I hope you understood this thing. Okay, now I'm supposing put this sine minus cos is equal to d. So let's find out the derivative. You will have cos plus sine dx is equal to dt. That makes my this expression as integral of dt upon 3 minus d square, which is equal to natural log of root 3. See, this is root 3 square, right? So this is a plus t upon a minus t whole divided by 1 upon 2a. Okay, so what does your fx becomes? Now this was your, see, let's compare it with 1 by 2 root 3 log of fx. So this is my fx. From here you have fx as a log. I'm ignoring that. Root 3. What was t? That was sine x minus cos x upon root 3 minus sine x plus cos x. Correct? Now you have to find out this whole expression at f is equal to pi by 3. So at x is equal to pi by 3, you have root 3 plus sine pi by 3 is root 3 by 2 minus 1 by 2 whole thing divided by root 3 minus root 3 by 2 minus 1 by 2. This gives me root 3 and okay, let's take the LCM only. Yeah, that would be better. So I'm taking the LCM here. 2 and this would be 2 root 3 plus root 3 minus 1 whole divided by 2 root 3 minus root 3 minus 1 whole divided by 2. 2 and 2 will cancel. So this will give me 3 root 3 minus 1 upon root 3 minus 1. So this is the answer to the question, and 3 root 3 minus 1 upon root 3 minus 1. That is, let's check with the options. Here you have option 8. Sorry, here was supposed to be plus 1 because minus minus it will be plus. Okay, so that's it. This is the answer. Root 3 minus 1. That becomes your option A. Hope you got that. Let's move to the next question, number 74. Students, before starting with this question is a quick reminder to visit our website www.examsnet.com. This site will be a great place for you to practice your entrance exam question papers. You must download our app. The link is available in the description box. For a better preparation, best of luck. Here we go with the question number 74 now. So question number 74, again an integral problem. We have lots of questions on the integral in this question, in this particular paper. So this is the one. Let's split it up. I'm opening this tan and tangent of x. Now this thing will be integral of 0 to pi by 2 x sine x upon cos x into 1 upon cos square x. Right? Yes. And this thing is divided by sine raised to power 4x upon cos raised to power 4x plus 1 dx. So ultimately this will be equal to integral 0 to pi by 2. This is equal to x sine x, and here you have cos cube x, and I'll take this thing in the numerator. So this is cos raised to power, this thing I'm taking the numerator, and taking the LCM at the same time. You have sine raised to power 4x plus cos raised to power 4x dx, right? So let's solve it properly. This will be cancelled, and 0 to pi by 2 x sine x cos x whole thing divided by sine raised to power 4x plus cos raised to power 4x dx. Okay, so let's say this is number 1. Now, you know one thing that I can convert, like if you are having the limits can be like a to b, f of a. This can be written f of x. This can be written as integral of f of a plus b minus x, right? Limits will be a to b. So same thing I'm going to do over here in this question. Now this will be equal to integral 0 to pi by 2 limits. This will be equal to x I'm changing. It will be changed to pi by 2 plus 0 minus x sine pi by 2 minus x, and cos pi by 2 minus x. Whole thing is divided by sine raised to power 4 pi by 2 minus x cos raised to power 4 pi by 2 minus x dx. So this will be equal to pi by 2 minus x. Now this will be changed into cos. So this will be cos x sine x. All are lying in the first quadrant, so all will be positive. So this will be sine, will be again, this will be this thing will be the same, right? Cos raised to power 4x plus sine raised to power 4x dx. Correct? Let's say this is equation 2. Now let's add both of them, adding 1 and 2, adding 1 and 2. You will get, let's say that was equal to I, okay, and that was also equal to I. So here you have 2I is 2I becomes equal to integral 0 to pi by 2, and here you have added, this was pi by 2 minus x, and this was x. So on solving this whole thing, you will have the pi by 2 sine x cos x whole divided by sine raised to power 4x plus cos raised to power 4x dx. Now let's put sine square x is equal to t. You will have 2 sine x cos x dx is equal to dt. And when x is approaching 0, t will approach 0, and when x approaches pi by 2, t will approach to 1. So now this whole integral will be equal to limits 0 to 1. I'm taking this pi by 2 outside, so pi by 2 is taken outside over here, and this will be dx, like this will be divided by 2, okay? This can be written like this. So this will be 1 by 2 into here will be dt upon, here will be dt. Now we need to do some calculations for this one. See, sine raised to power 4x plus cos raised to power 4x. This can be written as sine raised to power 4 x plus, this can be written as 1 minus sine square x whole square. Correct? So this will ultimately give me sine raised to power 4x plus 1 plus sine raised to power 4x minus 2 sine square x. So if I'm putting sine square x is equal to t, first of all, this is 2 sine raised to power 4x minus 2 sine square x plus 1. So I'm putting this thing, this, sine square x is equal to t. This will be 2t square minus 2t plus 1. Right? Same thing, I'm going to write here 2t square minus 2t plus 1. This whole thing was equal to 2i. That was equal to 2i. Okay. So this is, I'm writing it properly once again. 2i is equal to pi by 4 integral limit 0 to 1 dt upon 2t square minus 2t plus 1. Right? So your I now becomes pi by 8 because I'm taking the 2 in the denominator. This can be written as 0 to 1 limits dt upon, now this can be written as t minus 1 by 2 square plus 1 by 2 square, which is equal to pi by 8 tangent inverse t minus 1 by 2 upon 1 by 2, the limits from 0 to 1. So here you have tangent, pi by 8. This is tangent inverse. I'm putting this like 1 and the upper limit minus lower limit. So this will be 1 minus 1 by 2. That will be 1 by 2 upon 1 by 2. This will be tangent inverse 1 minus tangent inverse of, when I put this 0, so this will be minus 1. So here you have this pi by 4 minus and minus plus pi by 4. This will be pi by 8 and pi by 4 plus pi by 4. This will be pi by 2. So you have pi square upon 16. This is the answer to the question. It was a lengthy one, but it was an easy one. Only thing is the calculations were a bit lengthy. So you have here option A as the answer. Hope you got that. Let's move to the next question, number 75. So now you have to find out the integral of this given expression. Let's write this. You are given this. I'm going to use some properties. You're going to use the same property we used in the last question. Limit f a to b f of x dx is equal to limit a to b f of a plus b minus x dx. So now this integral will be, let's say this is equal to I. So this integral will be limit 3 to 6 integral of 6 plus 3, that is 9 minus x divided by 9 This will be 9 minus 6 plus 3, 9 minus x. So this will be ultimately x only. Okay. So this is root of x plus same thing, root of 9 minus x dx. Let's say this is equation 1 and equation 2, adding both of them. So when you add both these equations, you will have 2I is equal to limit 3 to 6. That was root x upon root x plus root 9 minus x plus this. So numerator and denominator will cancel. You will have this. So this is 3. Okay, that was equal to your 2i. That means I is equal to what? 3 by 2. So that's the answer. We have option B as the correct answer. Hope you understood this. Let's move to the question number 76, the next one. So now we have the limits before us. Okay, limit this whole expression 1 plus 1 upon n square, 1 plus 2 square upon n square whole till 2 raised to power 1 by n is equal to. Now let's say this whole thing is equal to p. Then further I will take log on both sides. So I'll have log p is equal to 1 by n will come ahead before. And here you will have log of 1 plus 1 upon n square plus, because these are in multiplication, so they will be plus log 1 plus 2 square upon n square plus log of 1 plus 3 square upon n square, so on. You have the log 2 in the end, so this can be written as log of 1 plus n square upon n square. Correct? So that means this log is equal to 1 by n, this whole thing 1 by n, summation of just a minute. Yeah, summation of from r is equal to 1 till n log of 1 plus r square upon n square multiplied by 1 by n. Right? Let's put this r by n is equal to x, and 1 by n is equal to dx. So this natural log of p will be equal to limit 0 to 1 log of 1 plus x square 1 by n. Sorry, this is dx. Okay. Correct. So now let's use integration by parts. Using integration by parts, you have natural log p is equal to log 1 plus x square into x minus integral of this thing, derivative of first into 2x into x dx, limits 0 to 1. Log p is equal to log, I'm putting the limits now, this will be log 2, yeah, log 2 minus 8. This is log 2 minus log 1, right? So that is 0 itself, minus 2 integral limit 0 to 1. Here also 0 to 1. Okay. Yeah. So this is 1 plus x square minus 1 upon 1 plus x square dx. So you have this as natural log 2 minus 2x minus tangent inverse x, because this will be 1 and minus 1 upon 1 plus x square. I hope you got this. See this thing, this can be written as this thing will be integral of 1 minus 1 plus 1 upon x square dx. So it will be x minus tangent inverse x, limits 0 to 1. So you have natural log 2 minus 2 into 1 minus pi by 4 and minus 0 and 0. So I'm just ignoring that thing. This will be natural log 2 minus 2 plus pi by 2. That was p. So what will be P equal to? It will be E. I'm removing the logs now. Right. So this will be E raised to power natural log 2 plus pi by 2 minus 2, or this is equal to 2 e raised to power pi by 4 upon 2. This is the answer to the question. And here you have option C as the correct answer. Hope you understood this. Next is question number 77. The area in square unit of the region bounded by this curve, positive x-axis, and this line is equal to. You obviously need to make the figure to understand this. See, first of all, this is the circle. Center, origin, because x and y coefficients are missing. So this is the circle with the center as origin, and the radius will be root of 64, that is equal to 8. So let's make, here is the circle with center as the origin. It's not appropriate, but this will be the center, not, wait. Okay, this is the circle with center and the origin, and let this be the line y is equal to root 3x. Of course, this is passing through the origin. Sorry. Okay, this is not a straight line, but it should be. Okay, so this is the line y is equal to root 3x. Of course, this is passing through the origin. So you have to find out this area, right? Look at the area carefully. Actually, this is this triangle plus this curve, correct? Now let's get back. You are having x square plus y square is equal to 64. And you are having this as so you actually have to find out the point of intersection of both of them, and this is the line y is equal to root 3x, so this will be x square plus y square is root 3x, which is equal to 3x square is equal to 64. 4x square is equal to 64. That gives you x as 4, because it's in the first quadrant. You can see I will not take the negative value for x because this is in the first quadrant. And for x is equal to 4, you will solve. Y will come out to be 4 root 3. So this is the coordinate where it is intersecting 4, 4 root 3. Okay. Also, this is the point of intersection of this curve with the x-axis. So this was for line, point of intersection for line y is equal to root 3x, point of intersection. Now let's find out the point of intersection on the y-axis. So here you have x square plus y square is equal to 64. So you will have x square is equal to, because this y will be 0. So you have x is equal to 8. That means this point comes out to be 8, 0. Okay. Now you have to find out the area of the shaded region. This is a triangle first thing. This is O. Let's say this is A, this is B, and this is C. So area of shaded region is equal to triangle area of shaded region is equal to area triangle OAB plus the area of the curve, which is from this point, B point, till C. Well, you need the coordinates of B as well. What will be the coordinates of B? This is 4 root 3, and this is 4. So B will have the coordinates as 4, 0. Okay. So now the area of this curve from 4 to 8, root of 64 minus x square dx. I hope you got this thing. I'm particularly talking about this particular region, this one, this much region only. This is from b is equal to 4 to b is equal to 8, area of this curve by the x-axis. Okay. So now area of the triangle AOB, this is half into base into height. Base is 4, height is the 4 root 3 plus integral. You have to find out it. So this is x by 2 root of 64 minus x square plus 64 by 2 sine inverse x by 8. The limits 4 to 8. So this becomes 8 root 3 plus, I'm putting the limits now. This will be 0 minus 2 root 48 plus 32 sine inverse 1 minus 32 sine inverse 1 by 2. That makes it 8 root 3 minus 2 root 48 sine inverse 1. This is 32 into pi by 2. And 32 sine inverse this is equal to 32 into pi by 6. Okay. So 48, this can be written as a 4, so 12 fours are right. 48 will have the roots as, wait, I'm just getting confused. So 4, 12, 4, 3. So here you have minus 8 root 3, minus 32. I'm taking common, pi by 2 minus pi by 6. These will cancel with each other. Yep. And wait, I have done a bit of, this was plus. This was plus. So this is supposed to be plus only. And here you have 32. This on solving, you will get 32 pi by 3. This is the answer to the question, 32 pi by 3. Option D is the correct answer. Hope you understood that. Next is question number 78. If A and B are arbitrary constants and the differential equation corresponding to the family of curves given by this equation or this expression is which of these options? So simple as that. You are given y is equal to x into A cos log of x plus B sine log of x. Let's find the differentiating both sides with respect to x. You will have this as a, I'm opening this up. First of all, you will have the dy by dx for xa cos of log x plus xb sine of log x. So now it's easy to go for. This will be first function derivative of second. So here you have a into cos log x plus ax into minus sine log x upon x. This whole thing plus b sine log x plus bx cos log x upon x. So that was your dy by dx. Here you have a dy by dx is equal to, this will be equal to, see, if I take this y by x, this is equal to a, this whole thing, y by x is this whole thing. You have this whole thing over here also. A cos log x plus xb, wait, yeah, plus this. So this is equal to, I'm taking these two terms as y upon x. Now plus minus a cos of, sorry, sine of, minus a sine log of x plus b cos of log of x. Okay, so that is it. So let's find out a second derivative. D square y upon dx square is equal to dy by dx into 1 by x plus y into first function derivative of second plus second function derivative of first. So here you have minus a cos log of x upon x minus b sine log of x upon x. So you have d square y upon dx square is equal to dy by dx into 1 by x minus y upon x square minus this thing is y upon, because the x, y upon x into 1 by x. So this will be d square y upon dx square is equal to 1 by x into dy by dx minus y upon x square minus y upon x square. So this will ultimately be minus 2y upon x square. Okay, so I'm taking the x square on this side now. This will be x square into d square y upon dx square is equal to x into dy by dx minus 2y or you have x squared dy by dx square minus x into dy by dx plus 2y is equal to 0. So this is the answer to the question. And we have here option B as the correct answer. Hope you got that. Let's move to the next question, number 79. Question number 79, if for the differential equation, this at 2 comma 1 is this, then what is the value of k? So that means, first of all, I have to find out a solution for this differential equation and then compare both the equations. Okay. So now you are given the equation as y square dx plus x square minus xy minus y square dy is equal to 0, or you will have dy by dx is equal to minus y square upon x square minus xy minus y square. Let's say this is equation 1. Now above equation is in homogeneous form. This is a homogeneous equation. So we will put y is equal to vx. So this equation now will be dy by dx is equal to v plus x into dv by dx. See from here, sorry, okay, I have written this. So yeah, so let's put this thing in equation 1. Let's put this thing in this equation. What this equation will become now? V plus x into dv by x is equal to minus v square upon v square x square minus x into vx minus v square into x square. So you have here x into dv by dx is equal to minus v square x square upon minus x square minus x into vx, which is vx square vx square minus v square x square minus v. So this becomes x dv by dx is equal to let's take the LCM and everything. So you have minus v square x square minus v x square minus this is this is not there, right? Yeah, minus v x square plus v square x square minus v cube x square, right? These two terms will cancel and the so will be x square minus v x square minus v square x square. Okay, so this ultimately is equal to taking the x square common from numerator and denominator and cancelling them. You will be left with minus v cube minus v upon 1 minus v minus v square. Okay. Yes. So in the over here, I'm taking this minus v common. So this is v square plus 1. Question number 79, if the solution for this differential equation at 2, comma 1 is given by this, then you have to find out the value of k. That means basically you have to find out the solution for the differential equation, which is given by y square dx plus x square minus xy minus y square dy by dy is equal to 0. So here you can write down dy by dx is equal to minus y square whole divided by x square minus xy minus y square. Now this is a homogeneous equation, which means we can put down y is equal to vx, so that also dy by dx is equal to first function into second function plus second function into derivative of first. So if I'm putting this in this equation will become that was v plus x dv by dx is equal to minus v square x square holding divided by x square minus x into vx minus v square x square. Let's divide numerator and denominator by x square. So we have minus v square upon 1 minus v minus v square, that is equal to I'm taking this v on the right hand side. So this will be this thing. Okay. Now further, this can be written as x into dv by dx is equal to 1 minus v minus v square minus v plus v square plus v cube, and these two terms will cancel. And I'm multiplying the numerator and denominator by minus, so minus of v cube minus v upon minus 1 minus v square. You will have this as v minus v cube divided by v square plus v minus 1. That is equal to x into dv by dx. Now this is equal to, I'm taking common, 1 minus v square divided by v square plus v minus 1. Or you have, I'm taking like, this is v square, I'm cross multiplying them, v square plus v minus 1 upon this dv is equal to 1 upon x dx. So this thing now becomes, this will be, I'm taking v plus v minus 1 minus v square whole divided by this is equal to this. This makes it 1 upon 1 minus v square minus 1 upon v is equal to this. So let's integrate on both the sides now. Here was dv and this. So let's integrate on both the sides. On integrating that, you will get this is equal to half log of 1 plus v upon 1 minus v minus log of v is equal to log of x plus, say, log of c. So that is natural log root of, I'm taking this half over here, so this will be 1 plus v upon 1 minus v under the root divided by v. This is equal to log cx, right? So here I'm cancelling the log, so you will have, I'm putting the value of v as y upon x. This will be equal to root of x plus y upon x minus y divided by y upon x. So this will be multiplied by x upon y. This is equal to c upon x. They will cancel out. And I'm putting the value like you have to find out at the point 2, 1. So let's put x is equal to 1 and x is equal to 2 and y is equal to 1. So you will have root 3 upon 1 into 1 upon 1 is equal to c, which gives you c is equal to root 3. Okay, so once you get the c is equal to root 3, now let's get back to our equation. What we had here was this. Let's get back to our this equation. Log of, let's say this is equation 1. So from equation 1, you have log of root 1 plus v upon 1 minus v divided by v was equal to log. Now c is equal to root, so root 3x. This becomes, this is log only. So this becomes, the equation becomes now y plus x upon y minus x divided by, or you can say multiplied by, x upon y is equal to root 3x. Again, an x will cancel. And here you have this is equal to 3y. Let's do squaring on both the sides now. So after squaring, you have y plus x upon y minus x. Sorry, this was x minus y, not, this is x minus y, because 1 minus v will give you x minus y. Y plus x upon x minus y is equal to, that was root 3, so 3y square. So you have x plus y is equal to 3y square into x minus y, or x plus y is equal to 3 into xy square minus y cube. Let's compare it with the given equation. You were given the equation as this, x plus y is equal to this. So given equation, x plus y is equal to k into xy squared minus y cube, which gives you k is equal to 3. So this is the answer to the question. Option D is the correct answer. Hope you understood this. So let's move to the next question, number 80, which is going to be the last question for this paper. The general solution for this equation is, all right, so let's write down the equation. You are having dy by dx plus y upon x is equal to x squared. This is linear differential equation. Linear differential equation. Therefore, here you have p is equal to 1 by x and q is equal to x squared. So integrating factor is given by e raised to power this, which is e raised to power natural log x, which is equal to x. So solution y into x is equal to this into x plus c, or x into y is equal to, this is x raised to power 3, which is equal to this. Okay. All right. So next, what we need to find out is, fine, we have to find out a general solution, which is given by this. Xy is equal to x raised to power 4 upon 4 plus c. Let's see. Here we have option C. This is the answer to the question. So students, with that, we have completed all the 80 questions of this paper. Hope you understood them well. And don't forget to visit our website, www.examsnet.com. Here you can find solutions for this and many more entrance exam question papers of similar type. Also, for better preparation, you must download our app. So students, a very best of luck. Keep shining, keep rising high. Do explore our website and our app. Bye. That's all for this paper.